tersimpul sekian lama. Gunung didaki, gelora dituruni, segera melangkah gagah seiring bersatu. Kita jalin tekad berpadu, menang bersama demi menghargai pengorbanan.
Okay, hi, good morning, everyone. Welcome to day 4 of the Women in AI Malaysia Summit, together co-organized with UTeM Malaysia. Congratulations for making it to day 4. We have interesting talks lined up for today. So for this morning, our first session, we have our WAI Masterclass 2. Looking at the wrong day, sorry. WAI Masterclass 4. Deep learning as assisted tool for pattern recognition and classification. So the speaker for today, we are very privileged to have Associate Professor TS Dr. Marina Yusof from the University of Technology Mara, UTeM, here to get this morning to share with us this WAI Masterclass, the fourth one. Okay, so just a brief introduction. Dr. Marina is from UTeM. Just give me a minute. I'm going to loading the page now. Just give me a minute. Okay, yeah. So Associate Professor Dr. Marina is from UTeM. She's a senior fellow researcher at the Institute for Big Data Analytics and Artificial Engineering, and her area of expertise is in big data and as well as AI. So without further ado, I'll hand the stage over to Dr. Marina. Dr. Marina. Yeah.
Okay. Thank you very much. A very nice lady, Maising, for introducing me. Okay. Assalamualaikum and good morning, everyone. We are here today to learn, to know something. If you are new on deep learning as assisted tool for pattern recognition and classification. Okay, before I proceed with this topic and the details about information of this regarding this topic, I would like to wish everyone stay healthy and be in a good health, and also happy Malaysia, Selamat Hari Malaysia. Today is Hari Malaysia actually. So happy Malaysia to everyone. Okay, so without further ado, I think I will proceed with the workshop. Okay, um, basically, just to add a bit about what Miss Chairperson mentioned just now. Um, I'm now at Big Data Analytics and Artificial Intelligence, or we call IBDAI from UTeM. Okay, just a bit info about IBDAI. IBDAI is a new center of excellence, which is actually upgraded from previous tier of center of excellence, or we call at that time a research group called Advanced Analytic Engineering Center. But now this Advanced Analytic Engineering Center became IBDAI in April 2021. So it is new. We are very new actually. And I'm also as a representative of IBDAI today, I would like to thank so much to WAI Malaysia Summit at UTeM, okay, for inviting us, okay, to share some of our expertise, our expert area, which is on of course, big data analytics and artificial intelligence. Okay, so there is a bit a brief about introduction of IBDAI. So let's move on to what we are going to do today. Okay, we have 1 hour and 30 minutes. All right. So what I'm going to do, I will follow this outline. Okay. These are the outline for today. I will start with introduction to artificial intelligence. Okay, before we actually start looking at details about patterns, about what is happening in data, right? So it is good for us to know a bit about the artificial intelligence. And then after that, I'm going forward to introduce you what is a big data, what is a data analytics. So we are going to know what is data analytic, what is the actually types of data that we face, okay, today. All right, and then we move on to further details about data. We will look into patterns in data. And then after that, we move on to look into how we can recognize pattern in data. Because this is the main part that we are going to know, right? Data is everywhere actually, but how to recognize the pattern in data? How do we know what data, what is the data about? We know now if we see them consciously, we can see the data right now. If you are in front of me in the screen right now, you can see the text here, right? This is the text. Okay, what you can see is consciously you see this is the text, but it could be behind the text here there will be something unconscious. Okay, like in our mind we have unconscious thing, right? So I believe in data also we have something unconsciously driven. Okay, so that we need to find what are the information under the unconscious data pipeline. Okay, so and then I will share here today about the focus scope actually, looking at the practical application with ML. ML is machine learning for binary classification. Okay, for your information, today we will look into binary classification only. Okay, so and then we will focus on ML and also deep learning. Okay, I will share these two practical application using Python language later. Okay, that is overall about what we are going to do today. Okay, I hope you are ready. I'm not sure your background actually, but I assume here this is the workshop is like a very introductory course, but even though it is in introductory course, but I hope end of this workshop you have an idea to apply, okay, your data for binary classification. For binary classification, and we need to look into later what is binary classification and what type of data that can be used for binary classification. Okay, so let's move on to the first part. Okay, now I would like to just give a brief introduction for to those who are new in artificial intelligence. So I prepared this to ensure that we are in line. We are in line in terms of if we want to use later the solution for the pattern recognition. So I will start with some kind of introduction on AI evolution. Okay, for your information, this screen, what I am showing you just now is it is from my ebooks actually. Okay, my ebook. So I just use the ebook information to share with you guys. Right. So in this figure, we can see the evolution. Okay, so we can say that AI starting long time ago. Okay, long time ago, way back 1840s to 1915. But 1950s is the most greatest significant, okay, for the AI to point out, okay, based on Turing test. And from the Turing test is move on. I don't think I will share everything here, but to give you the idea, yeah, the evolution. So we can see from here through this line of timeline, you can see the importance of AI. So starting from Turing test until up now 2021, we have many application or many solutions to AI. For instance, we have AI in mobile apps, machine learning, deep learning, and also we have in our internet right now, we have Facebook. How Facebook actually manage their information at the back end. Okay, most AI also help assist them. Also, if we look at the Amazon.com, and also many things like IoT solution and also chatbots. Okay, most use AI methods at the back end. Okay, to support the automated processes. Okay, this is about AI evolution. And when we look at the importance of AI also has have many rules. Okay, this here I highlight 5 example of subfield in AI. Okay, the first one is machine learning. We will look into later about details, a bit a detail about machine learning and deep learning, how it blend together. Okay, and then we have also in AI knowledge representation, automated reasoning, which is important in our life, yeah, in the problem, in a real problem nowadays in the world. Okay, automated reasoning, natural language processing, and robotic. Of course, many people, many normally school students normally always when we talk AI, they think about robots. Yes, it is true, because how we program the robot, we use AI capability there. Okay, to run the robot. Robot is only the frame or iron or any kind we call a metals, can. But how we move them? So we need instruction. So the one of the instruction that we need to embed in the robot is from the AI methods. Okay, there is AI roles, and then moving towards example of AI roles in business process, because nowadays if you look in the industry, there are demanding. Demanding. Of course, if we look at the information system right now, information system that we have like information management system, human resource information, like how we apply our leave, right? All them are information system. But nowadays, most of the system are upgraded, okay, upgraded and embedded with AI element. So with AI can support more on the performance of the organization. So it support improvement. There are many. If we talk about performance improvement, there are many things to discuss. But here I just give a brief. Okay, but AI can support performance improvement of the company or organization or in the university. Okay, and also AI will support efficient decision making. One of the example is when we deal with AI, like just now I mentioned about here, right? The expert system. Long time ago, the first expert system has been introduced. Okay, what expert system can do is like helping. Expert system can help for efficient decision making, where expert system can give a suggestion. Okay, when we have a back end knowledge and then we apply the expert system methods, then we can come up with certain suggestion. So it will be like that. Okay, so now this is example what business process, the role of AI, what are the benefits, okay, from the AI role, from the AI. Okay, the first one is automated business process. Of course, it's not AI alone, but it embedded with other tools. Okay, and then number two is obtaining insight through data analytics. Okay, this is nowadays is very demanding when it is reflect to the we are in the era of IR 4.0. Okay, so data, nowadays people talk about data everywhere. Okay, but data is actually established long time ago. We have a big data long time ago, right? But now we are more realized about data. All right, and then one of the AI role that can help is customers and employees engagement. Of course, more than this, right? This is only example. Okay, more specific example. This is what I share here is one of the role AI in surveillance. Okay, surveillance. There are many things actually AI can do. This is example of surveillance. Surveillance, it can be we can do surveillance at our house. We can do surveillance in the smart city. We can do surveillance in the forest. Okay, this is example surveillance in the forest. This is I share here actually one of my project with industry. Yeah, so we did on improvement in terms of human monitoring to AI monitoring. Of course, here when we did human perform AI and we deal with data here. In this case, we are dealing with signal data. Okay, we will look forward to see what is signal data later a bit, yeah. But here the solution is more on signal data because the current solution using camera require a lot of cost. Okay, camera, and it's very hard in terms of the degree of viewing can for the camera. But if you signal, we can see 360 degree. Okay, we can see 360 degree. And of course, the role of AI, what other AI can benefit is more on surveillance time. It can be 24/7 surveillance. Okay, if you have a manual monitoring, then it will be depends on the time, and you need a particular people, staff, okay, to be there in the forest. Okay, and then another one is in terms of cost. Of course, when we come up with a new solution, we want to reduce the cost. Okay, that is example of role AI. I'm not going to detail about this, just overview, yeah. But AI evolution. Okay, this is more about nowadays. If you can see from here, I just jot down few here. But this is the main. These are main elements, main field, or main problem, or main criteria, or we can say main field, yeah, main field or main area that AI technologies can support. Okay, looking at this IoT, big data, computing processing power also important because now we deal with large data, right? And also, of course, I believe that you know about autonomous vehicle right now, right? And also moving towards in terms of healthcare technologies, like nowadays we have COVID-19, and so I believe that AI also can um, play a role, okay, in helping or in assisting COVID-19 pandemic issues, okay, and also in agriculture. Okay, so you see here AI is important. Later, I will share with you also where is the patterns in AI. Yeah, okay. So we are trying moving towards to data. Okay, now so AI evolution actually one of the concern is on data. Okay, I hope you are fine. Yeah, you are fine. You can follow me well. Yeah. Okay, so AI has impacted and improved solution to many real world problems. If you Google about AI, what AI benefit, you can see many things. As I mentioned just now in this area, right? So we can say AI has a future impact for industry and human life. AI is an enabler for fast growing technology in this present and future. Okay, AI is an enabler of fast growing technology in this present and also future. This is a good things here. Okay, so AI also, as I mentioned just now, will harness the industry 4.0 and address societal, economic, and environmental issues, especially in the nation, the United Nation drafted on sustainable development goals. I believe everyone knows about sustainable development goals. There are 14 elements there, uh, all talking about the improvement or the sustainable about the world. All element in the world, including people, including organization, yeah, including also partnership, environmental. Okay, so it is in SDGs. So okay, so addressing this issue involve a substantial variety and volume of data. Yes, when we deal with real world problem, like what have been taught in SDG also, it will involve variety and volume of data. Variety means many types of data and many features in the data. Okay, volume means large data. It's not sometimes small data. You have a small data even when or your company or you deal with a small data. Sometimes we are not um, we are not going we did not have any solution yet, even a small data set, right? So it's okay, it's okay, don't think much about large data, but try to solve what you have right now, and then moving towards the large data. Don't worry about that. Big data is actually overall terms about data. So if we have a small data, then you can proceed with. Don't worry about that. Yeah. Some because I experience with student, kan. Oh, I want to do big data. I want to do big data. So I ask, how about volume of your data that you have? Okay, how big is your data? Can so that is sometimes people has different talks about big data, but it's okay. What we want to do is to solve data, alright? Okay, so in order to solve data, I come up with 3 points to ponder here. Okay, the first one is how to uncover data. Okay, we have data like you have in the screen right now. You have text, kan? But how to uncover this kind of text? What does it mean behind there? Okay, and how to obtain insight data? Okay, how to obtain insight data? There is something in the data. Okay, but how to obtain it? Okay, and then how to analyze and interpret insight data? Okay, so let's move on. I hope you are ready. Yeah, we are continue now to introduction to data analytics. Okay, okay. So data analytics is based on when we coin data analytics or people talks about data analytics, many people thinks about data analysis. Okay, point out about data analysis. So here, this is my based on my view on the data analysis. So data analysis refer to examination, transforming, arranging of data, and extracting useful information. Okay, so this is about analysis. Normally, we analyze data to get some useful information. Um, okay, but for me, it is a bit different term coined by data analytics, meaning data analytics is a discipline of complete data management, meaning that you have data, source raw data, and then what is happening to the data, like we mentioned just now, how we uncover the data, how we find the insight of the data. So we go deep, um, deeper and deepest, okay, about the data. Okay, so here I list out four steps in data analytics. This is the general steps, so that if you are new in this data analytics, you can we can just like, oh, there are four steps in data analytics. Okay, so the first one is reviewing data from past. Okay, of course, when we look at the data, we look at the data, the historical data or data that we have right now. But sometimes, if we want to look at the more detail to uncover the data, we need more data from historical. Okay, so and then how we review data from the past event needs experience. So you need to have data in you and play around with the data. See it. Some people use visual dashboard. Okay, visual dashboard to see what is actually what is all about that data. So they use visualize like Power BI, for instance. My students always use Power BI to visualize the data. Let's say the student want to do sentiment analysis, right? So when we look at the sentiment analysis processes, one of the step is we need to get all the sentiment. Okay, let's say in Twitter. So you retrieve all the sentiment in the text or in text or in icon, put in the computer. And then what you need to do is you need to look at what is actually information that you have. So one way of to look at it is by visualization. So when you want to review, visualization can help. So okay, so the second one is the examining data to uncover hidden patterns and or possible correlation. So when we have data means many types of data. We will look it later. Yeah, what type of data? Let's say you have images. You have many images, many type of images. So how do you see the correlation within the image? For instance, my project with one of the company looking at the X-ray images. Okay, looking at the X-ray images. When we have that image, we need to see what is a possible correlation within the images. Is there any categories? Is there any possible subcategories for that? So we need to look into, okay, in details. Okay, and for the third one is to perform knowledge discovery to attain new knowledge from the data patterns. Okay, this one we need methods to do. Okay, explore the potential insight from data of the patterns. Okay, for the patterns. Okay, and then when we have the idea of these four steps, then we can think more advanced about how to do it. Yeah, so actually this ebook will give guide actually how to perform to understand and practice all the steps. Yeah. Okay. Okay, before we proceed to details about pattern classification, I would like to share with you the connection within AI and data analytics, because later we want to show that how AI methods can help in uncovering data, okay, for data analytics. So we want to see what are the connection there. So we can say here that AI and data analytics are depending um, on each other. Okay, AI with the capability to act and think like human. Okay, this is a fundamental of AI. When we talk of AI, normally we talk about the fundamental of AI also, looking at the act and think like human. Normally, we have four things, right? AI is like act like human, act rationally, think like human, and also think rationally. Okay, that is the basic element in AI. So if we want to be to know AI, we need to understand that four elements. Yeah. So the capabilities of act and think like a human is a great tool. It's a great tool to assist in uncovering and create a new knowledge. Okay, because of this element, AI try to have, okay, for um, to uncover and create new knowledge, or we call data discovery. Yeah. Okay. So data analytics processes require a viable procedure and AI methods. Okay, for instance here, normally when we talk about data, people always link it, correlate it with machine learning. Okay, with machine learning, AI is a big thing actually. Okay, but for the sharing today, we will look into machine learning. But AI is the the main, if you have father and child, so it is a father. Okay, AI is a father, and then the machine learning is a child or daughter or son, right? Okay, and then you have here data analytics, so it would need it to perform data analytics, it should be connected and work together right here, right? Okay, so as we know that AI has a future impact, and AI also one of the prime driver technologies for big data. AI also can be said as AI driven data analytics because AI methods are employed in data analytics solution. Okay, and many companies use popular machine learning methods for analytics. Okay, so let's move on to understanding data. So data are more concentrated in data patterns. That data analytics are more concentrated in data patterns. Okay, so I think I will go straight away to look into type of data. So we have data here. You see, there are more than this, but this is example. Okay, cloud data. You have in data can be in database or in cloud or not in cloud. It depends on your problem or your data where is you store the data. And we can have a type of data: text data, signals data, images data, survey data, gate data, or many other data could be falls under type of data. Okay, so normally people talk about three categories of data set. When we have data, we can categorize this into three. Okay, normally people talk about these three lah. Yeah. Okay, so the first one is structure. Structure is more structured, like we have a database, a very solid good database in the company. So and then the probably database too, if you have a database, but the structured one is normally we need a labeled data. We need to consider labeled data, okay, for machine learning. Okay, even though that you have already with database, but labeled data is important. We'll see later why we need labeled data, but not all need labeled data, but only for the classification we need labeled data. Okay, unstructured data, you can have unlabeled data. Okay, audio, video, social media. However, let's say you have images, you can also have give them a label. Okay, there is a process of preparation of data, and then semi-structured, a combination of both. Okay, this one also, okay, let's move on the we in data. We's in data, many okay, if we search in internet Wiz, they will come out with several number of Wiz. Last time I look at Wiz, it is more than 14. There are so many names. Okay, but it's okay of the name. As I mentioned, we are actually for our focus is to solve or to uncover what the data is, right? So don't worry about the we. Okay, but it is good if we know a bit about we. Okay, so we is about to describe more meaningful data, so that when we have here, we have the volume, velocity, variety, veracity, and value. So if we can understand, can dig more detail about this we, it is good for us to understand more about data and to mesh it with the solution later. Okay, let's say you have a volume of data. Volume mean it can be small, it can be large, it can be medium size of data. Okay, so but when we want to solve with let's say AI methods, or we can say machine learning method, then we need to know what is a suitable machine learning method that can deal with the um, volume of data. Let's say we use a large data set. Okay, is it enough for, let's say, one of the method, neural network? Okay, artificial neural network can solve for large data set. So we need to mesh it out. That's why the the way how we can look at this we is like that. Okay, same goes to the velocity. When you have velocity, so there are velocity means it could be new data, okay, needs to be stored and created. And also if you look at the variety, heterogeneous data set, for instance, I think I will share a bit about this variety. It's easy to understand. Okay, variety means you have very many types of data. Let's say you have a nominal data, ordinal data, or text data, right? So you are combining together, or emoticon data, okay? So you combine it together. It's we call heterogeneous data type. But how to solve it with machine learning, for instance? Which machine learning is suitable? That's why the we is important. So we can be a guideline, one of the um, um, guideline, okay, to map with the methods later. Because when we want to solve something, okay, in data, we always if we as a researcher, normally we always look back. Okay, we always look back to the previous solution or benchmark solutions. Okay, so from the benchmark, we can get the idea what is the methods to be used, okay, for that particular data. Okay, so I hope you can get the idea now, yeah. And then the last one is value, a significance of data. Significance of data means how do you see that data? Because we have a lot of variety of data, we have volume of data. Let's say 10,000 of data. Do we need to use all the data? Okay, so we have to consider which one is significance, okay, to be used to bring forward, okay, for a pattern, to find a pattern. Okay, so I believe that all. I don't think we have a break, right? Just continue, I think. Okay, so let's move on to patterns in data. Okay, so okay, now we start to look into pattern recognition. I think you get an idea already. I have introduced to you the AI. Okay, and moving towards just now about data and also patterns in data. So we have a like a flow there. Okay, if you are new in this area, so you can have to see, you can see the flow. Okay, the flow. And now when we understand what type of data, all right, what is actually what AI role, and then now we proceed with the pattern recognition. Of course, we can say that AI can do many things, or machine learning can do many things, right? But now we look into pattern recognition. Okay, pattern recognition, a pattern in data can be seen physically or observed mathematically by applying algorithms. So we need algorithms, we need a procedure, we need an engine, okay, to find the patterns. Okay, but for mathematician, they come up with the mathematical way of doing it. But because we are in AI right now, so we are using AI algorithms. Okay, so pattern recognition is a fast growing field. It is somewhat challenging to, however, it is somewhat challenging to identify and well dependent on the type of data and the width. This is what I mentioned just now. Because pattern recognition, we can say many people talk about pattern recognition. Okay, you see something, okay, you say that, oh, that is a pattern. Of course, if we look at how we think also, we are looking at the pattern, right? uh, if we can communicate, with the participant, then it is good. We can have a chit chat about what is pattern recognition. What do you understand about pattern recognition? For me, I will go many possibilities in pattern recognition. Okay, if we look in the data has pattern. Okay, if we look into how our mind work, okay, it is a pattern also in our mind, pattern of information that was recorded in our mind. Okay, it's actually reflect what we are going to behave, or we are going to do physically. So it is based on our mind. Okay, patterns in our mind. But nowadays we are not looking into that. We are looking into data. Okay, so few areas of pattern recognition were established, such as image processing, signal processing, text processing, natural language processing, document analysis, and many more. Okay, because of everything is about data. When we talk about image processing, it is about data. Signal processing is about data. So text and document, it is about data. So everything is about data. Okay. uh, okay, in addition, the source of data can be one of the consideration. Source of data, because when we want to think about pattern recognition, okay, source of data is important, because we need to know where is the data, how to bring data to your visualization, how to bring it. Okay, let's say I give an example for my project in the forest. So we need, if we are in the forest, to capture data. How do we how what is the method that we can do to capture data? This is not processing the data yet, but capturing data. So bear in mind, when we want to do pattern recognition, we must let the data ready. Okay, there are many processes actually involved when we want to get the data ready. I'm not going to tell details about this in this workshop, but just give you make you think about where to get the data. Okay, sometimes we know that we have a lot of data everywhere, but how to get data? Let's say I give you an example. We want to do a COVID-19 project. Let's say, wow, we think that we are very interested in COVID-19 data, or COVID-19. We want to actually involve, okay, in the COVID-19. But how to get the sources? Let's say you want to look into how we can detect images of COVID, okay, of X-ray images of COVID-19. Do we have source of data? Okay, at first round, of course, we think that, oh wow, it is very difficult. We need to go to Ministry of Health. to deal with people, to get the concern of ethics, to do the to in order to get the data. That is how the processes of getting data. But it will depend on how is the status of the data now. Is it a premier? Is it a primary or secondary data? Okay, so it will depends, and how difficult to get the data. Okay, so but for the student, if I think student also are here, right? For the student or researcher like me, in the university, normally we always use the benchmark data. Let's say COVID-19. What I have figured out that COVID-19 X-ray images also has their own benchmark. So you can go to find out through, probably use the keyword is COVID-19 benchmark data sets. So you can get the data from there. But please take a reference, put a reference in your work, okay, for that data, so that we know where is the data from. Okay, so it is the source of data. So when you get the data and you start thinking about what I mentioned just now, you start review data and everything. Then from there, normally we always think about what to do next, okay, based on that data. So here I list out 5 possibilities, okay, to look when we have data, where we should go after that. Okay, do we need to look in terms of recognition, or do we need to look into diagnosing, or we need to look into classification or clustering, anomaly detection, or looking at, for instance, conversation or human interaction? More than this is an example, okay, 5 examples here. So let's say we look at the classification. So when we look at the classification, what we need to go a bit details about what is a classification actually. Okay, another example is anomaly detection. Okay, if we want to do anomaly detection, so what is next? So from here, this is a guideline for you to move on. Okay, you can pick up which one, and then you try to move on. What are the next steps? Okay, for the details. But before you move to each to one of these, let's say you have data, then probably you can just view about find out the brief overview about each of these. But in this ebook we have this detail. Today I'm not going to share details about this because we want to do some practical work just now after this. Okay, so you can go detail. This is the tips lah. When you have data, you look at the data, you visualize data, see whether you want to recognize, you want to diagnose. The recognition here mean more to detect lah, just to detect. Okay, and then classify. You want to do anomaly detection or anything, or sentiment analysis, for instance. So you start with that. Start with the try to view on what is the next step in pattern recognition, because pattern recognition has many things. Okay, so if you want to look all in details, it's very hard. You need more time. So I give you tips here, so that when you have data, you need to know. You need to consider which part of this. Then you can go deep and deeper. Okay, looking at the solution. Right. So today we want to, okay, so for the title of the workshop is, we are looking at the pattern recognition and also classification. So I want to share a bit about classification here. So classification, normally we divide it into binary classification and multi-classification. Okay, for binary classification, normally 2 target output we have. Remember the classification, when we do classification, we need data that has labeled, meaning that you know the data. Let's say you have, after this, I will show this. Yes? Okay, so that you get the idea. Okay, binary classification and multi-class. Multi-class mean you have more target output. Okay, more than 2 targets. Okay, binary, let's say you have, you want to know whether it is, let's say, cat or dog. Okay, cat or dog. So 2, right? So if multi-class, let's say you want to know it is cat or dog uh, or fish. Okay, so you have 3. So more than 3 output there. But in order to get the output, you have data about them. Okay, you have data about the cats, about the dogs, about the fish. Alright, about fish, about dog, and about cat. So you need data that data, and you forecast to 3 targets there. So we call multi-classification, more than 2 targets. Okay, so pattern recognition for classification is one of the widespread pattern recognition. Many people actually, depends on the problem, but nowadays if you look, a lot of issues, okay, reflect to classification solution. For example, predictive prediction of it is a multi-class prediction of credit scoring, for instance, in finance. So it is a multi-class, or it can be also binary. Depends on the situation, depends on the data, depends on the how much that you want to uncover it. Okay, classification data will be based on observation of the data inclusively. Okay, I mentioned just now about primary and secondary data, and then classification data requires labeled data. Okay, these are example of classification problem. For instance, classify email, classify handwritten character, classify customer behavior, classify disease severity. Okay, classify timber grade, for instance, A, B, C. So this is multi-class. Okay. Okay, we can, it will depends on the data. Okay, let's look at the sample of classification of patterns in data. Okay, okay, we have here, okay, for this data, we call it a structured data because it is very nicely stated here. Okay, this data source is from UCI machine learning. I think you can go to UCI machine learning and find out this data. Okay, for your information, here we only take 14 attributes because of course there are more attributes to make it more significant, a real problem, but this is only example. We took 14 attribute, include the attribute of target. Okay, this is what I mentioned about target. Okay, so you have list of data here in a row. Okay, this is the hidden one is the description of the each of the element or of the attribute there. So we have here age, sex, cholesterol, for instance, old pig. Okay, there are if you know more detail about this, there will be a description, okay, in the UCI machine learning. This is from Cleveland data set. Yeah, so these are targets, okay, here. So if this particular patterns, okay, this particular pattern, let's look at the first row. Yeah, if this particular patterns, you can see there is a target there, 1. Okay, so but if this particular patterns, okay, the target is 0. Okay, of course, there are a lot of data for this. About, I think this benchmark data has about 300 something, yeah, total in total. Okay, so these are the data set. I hope you can get clear about the meaning of label. This is label, but this is in terms of this. But if there is an image, it could be different. Okay, probably. Okay, here example of tuberculosis images from Shenzhen dataset. Okay, we can say whether it is unstructured or structured. It depends on us lah, because when we sometimes we do some cleaning for that data, okay, we can put them in a structured way. Okay, but sometimes the sources, the original sources, is unstructured. Okay, it will depending on that. Okay, Shenzhen. Okay, target output is on, we look here on tuberculosis. TB is tuberculosis and normal. Okay, this is example of label. We label this TB. There are a range of images under TB, false under TB and normal, and we have the label already on that data. Okay, so strategy how to recognize pattern. We move on to how to recognize pattern. Okay, before we want to go detail about recognize pattern, I would like to add here a bit about understanding data analytic expectation, because there are three ways of analyzing data. There is a popular one. Okay, popular one. Sometimes researcher put into these three categories. Okay, the first one is descriptive analytics, predictive analytics, and prescriptive analytics. So descriptive is more on what has happened. Predictive is more what will be happen. Okay, let's say we have just now data like this. Okay, so we have this original pattern, and then when we apply this into machine learning, then of course we need to test it out, right? When we test it, then we use a new data. So when we have a new data, we want to see what will be happen. Okay, what will be happen. So for this predictive analytic, we use past data for prediction of the future outcomes. So a decision is based on the future prediction goal. Okay. Here in this workshop, we are focusing on this predictive analytics and specifically on classification. Okay, so prescriptive is more advanced. Okay, looking at what is happening, looking at the outcome. Okay, all right. So let's move on. Okay, I think I have 30 minutes more. So I hope that you can get the idea from the flow just now. Okay, now we go straight away to pattern recognition processes. Okay, pattern recognition, normally we have five here. I put here five here. Of course, there are sub processes in within the line, yeah. Okay, so the first one is identification of the source data, and then data preparation, data pre-processing, feature extraction, and pattern recognition model. So these are the general idea. Okay, you need to know the source of data. I hope you understand a bit about how to look into the risk and also source of data. And then data preparation and pre-processing. Data preparation and pre-processing requires time. Actually, more than about 80% of the work more on data preparation and pre-processing and feature extraction, because these are the big deal here. Because we need to understand, we need you if you want to be data analytic expert, you need to be expert in this. Okay, you need to be expert in the looking at the data, meaning that data is like data patterns is like in your heart already. Okay, you must be like that, because from my experience, when we deal with data, at first we are like, wow, it is very hard for us to see the data. Actually, what I mean to see the data is not just see, but it's about we see the data inside. Okay, inside. That's why we look at the inside of the data. So when we perform this step, data preparation, data pre-processing, and the feature extraction, we look in deep the data. In deep the data. And then after that, then baru kita go to pattern recognition model. Pattern recognition model is a method. It's a method. It's a solution. It's algorithms. Okay. Here also we need algorithm to do preparation, pre-processing, feature extraction, and so recognition model. But this is the hard work. I think who are familiar with who are dealing with data analytics, I believe that you feel the same. Okay, you feel the same. Okay, okay. So now when we understand the processes, now we want to look at where is the machine learning, where to find the pattern. Okay, so we need to understand a bit here. I want to share about machine learning methods. Yeah. So pattern recognition is like it's a processes that computers to learn from the patterns of data. So we want a computer to learn, okay, to learn as AI just now. Okay, AI can think, can act rationally, but now we look at the learning path. Okay, how the computer can learn. So one of the algorithm popular is machine learning, or the popular area is machine learning in AI. Machine learning can be used to detect and classify the patterns. Right. So I think can we look into this diagram now? Okay, we have here. This is my view. Okay, I'm not sure. Some people probably has a bit different perspective, but in based on my experience with AI for about more than 20 years. Okay, so I an experience in the projects of pattern recognition, data, various type of data. So I put this diagram. Some researcher also put like this. Okay, AI is the main, and then inside AI we have ML, the machine learning, and DL at the inside it. Inside ML, it is DL. Okay, deep learning. What I can say here, AI is the main thing, and then machine learning is one of the sub AI, which is a pattern, looking at the learning pattern, and then DL is more focused on ML. Okay, more deep, looking at the looking at more sophisticated architecture. Okay, right. So let's move on. Okay, now we move to practical. Okay, practical application with machine learning. Okay, I will start with machine learning first, and then later we go to deep learning. There is a reason behind that actually, yeah. But for your information, in this workshop, I will share about the one of the deep learning. Okay, deep learning that needs ML, needs machine learning. Okay, to establish. Okay, to establish. Right. So let's move on to step for classification. This is more or less similar to this one. This is very general, but this is more focused on classification. So what we can do from the classification is, okay, of course we need the data, and then we need to prepare everything about data. If the data is nicely there, then it is very good. We can smile happily. Okay, we can smile because data is there. Because you know that the hard work, okay, most of the time is on data preparations. So if data is clean, then yeah, it is very nice, superb already. Okay, and then we proceed with the feature extraction, and also we proceed with ML or DL. Sometimes, bear in mind, yeah, when we use DL, sometimes feature extraction is in there. Okay. For instance, just now, after this, we want to use one of the deep learning, or one of the deep learning solution is convolution neural network. Okay, it's convolution neural network can perform feature extraction also. Okay, so here it will depending on how you apply it. Okay. Okay, so next, after ML or DL algorithms, then you go for training and validate. You validate the data that you have, and then you perform the training and validation for that model. Validate here to validate the model, okay, from the training. And then the model, you get the predictive model, right? Now you get the model is established. Then what you need to do is, when you obtain the model, then you can test it. Okay, when you test want to test, you need to test using a real data. Okay, real new data. So you need to input the new data here, and then test using that model, and you will get the results here. All right, so we will look into how it works based on this. Okay. So this is illustration. Okay, let's move on. Okay, before we go details, I need to just highlight a bit about MLP. MLP is, okay, ML, when we think about ML, there are many methods in ML. Okay, like if you are familiar with popular neural network, artificial neural network like perceptron, backpropagation neural network. Yeah, another one is multi-layer perceptron, or sometimes we call also feed forward. Okay, feed-forward neural network. Okay, so here I want to share about MLP, multi-layer perceptron. Multi-layer perceptron is one of the artificial neural network methods. Okay, um, okay, now MLP, or we call MLP or feed forward. We can say also feed forward. Okay, so it is commonly used in implementation of deep learning with convolution neural network right now. For instance, if you use one of the example of convolution neural network like VGG19, ResNet, ResNet, DenseNet, and many things there. So normally they are comply with the MLP or feed forward layer. Yeah, or we can also we can or not use MLP, okay, at the classifier, but normally for easiest, okay, for this workshop, I will use MLP. Okay, so in MLP there are three layers: input layer, hidden layer, and output layer. So this is basic of neural network actually. If I hope you guys get idea about neural network. If you want to understand neural network, I think we need to have another workshop, okay, to understand details about what is happening inside. Okay, so okay, for the just a brief idea. So in MLP, we have an input layer. You have the data inputs. Okay, let's say you have data like this. Uh, okay, I think later lah. Later I show. Okay, you have input layer, hidden layer, and output. Output mean the targets. Okay, let's say you have target data just now about 0 and 1, so you have two target. This we call this the circle one, yellow, gray, and blue, we call neuron. Okay, in neural network, because neural network reflect to our brain, how our brain works. Okay. Okay, if you go further, then you can also search what is artificial neural network. Then you can see what is how artificial neural network imitate our brains. Okay. Okay, so let's go for case study one. Okay, I'll share here case study one. Okay, the case study one, we use heart disease classification. Okay, the data that I show you just now, the example is this. Okay, so we use this, okay, to show the MLP part, to see the patterns in this data. Okay, let's move on to this one. Okay, MLP for heart disease classification. Okay, this is a clean data set. Yeah, we are happy. We can smile because we have a clean data set, right? So type of classification, binary, okay, because we have to target output only. 0 is present, mean the heart disease present, and 1 is, 0 is not present. 1 is present. Okay, so our programming language, we use Python libraries. Okay, here normally we use TensorFlow. Okay, TensorFlow we have when we use TensorFlow, normally we add on the Keras and also NumPy. Right, this is a basic lah. So when you want to do you run your Python, so you need this library. Okay, so these are the steps to be used. Okay, the first one, we need to load the, okay, in this case, I'm using CSV format. Okay, you can use other format like text formats or any formats. Okay, sorry, here, step 2, repeat. Okay, step 2, then we need to prepare data sets and we need to find MLP. Prepare means it's not prepare like what we do to clean the data, but to prepare for the Python to understand. Okay, and then define MLP model. Okay, now we need to define the MLP model and training the model and testing. Sorry, DL. Testing the MLP here. So the MLP model. Okay, so let's move on. I hope you are ready with this. I'm not sure if you are familiar or not with Python, but I'm also learning Python all the way, because I believe that when we try to solve the problem, for instance, like machine learning, deep learning, if you ask me, I would prefer to use Python. Okay, Python is, if you are familiar with Java, C++, so what I can say, Python is a fingertip programming because it is a high level. Only that sometimes it's very difficult also for hardcore programmer because it is so highly level. So we need to understand the library behind. Okay, what is the function that we need to call? Okay, for instance, here you have you import from keras dot models. How do we know we need models there? Dot model. Okay, we need to call the instances model. So that is the thing that we need to know. Okay, we are not creating on our own, but we use it. Okay, all right. So let's move on to Python code a bit. Okay, here we start with retrieve and load data. I believe everyone knows about this. Okay, this is depends on your data. So here in this ebook, I explain a bit lah here so that because I foresee when I deal with student, especially student lah. For me, is a student. But if you are from industry, you want to learn about this one, it's okay because here we try to give a layman understanding about the application of the MLP or the L or CNN in Python. So we try to make it in flow. Okay, so for instance here we use NumPy. To run ML we use keras, and then load the hard disk data set. Okay, store the same folder. Okay, here store in the same folder to be easiest. Yeah, but you can have your own if you are good. You can store in any folder. But this is I just want to say that with I'm trying to share with you easiest to flow. Okay, so that if you are student, you are not sacrifice yourself. Okay, to understand because there are many sources. It's okay, you can go to internet and everything, but here I'm trying to give a simplified way, right? So you have here two data set here, we have a hard data set, so we can have the output here when we print the data. You go so that we can see. Of course we can know more to visualize data. Okay, we can visualize data using this Python code also. Okay, let's move on to MLP. So I think I will go fast because I need to show the L also. Okay, so this is about the preparation of data set. Okay, we need to prepare data set. Here I use NumPy because X and Y. Okay, X is the input feature, Y is the output feature. Okay, and then we need to define the MLP model. Okay, this is just use it this. Okay, normally the activation ReLU. Okay, to understand more detail about this activation function, okay, we need more. We need more times, yeah, and then the activation. But I write here. Okay, this is the architecture. Okay, I write here a bit about the explanation. What is ReLU? What is sigmoid? Okay. Okay, the activation function. But if you want to understand more detail how activation function work, how sigmoid work, we need to understand details about. Okay, if we understand neural network, then you get the idea from there. Okay. Okay, so let's move on. Step 4, and then now you train the model. Train the model, just use the model that fits. And then put the X and Y. X is the input, Y is the label, and then input features and the label. And okay, these are the validation split because normally in neural network, finding a pattern, when we want to train data, we need to split. Normally 80%, 80-20 or 70-30. Okay, 70-30 of data that you have, you want to split into training and validation. Okay, so here epochs is 5. Okay, epochs is the iteration. Okay, for each of the generation. Okay, so we evaluate based on accuracy and loss. All right, so here the explanation a bit. I give a very simple explanation about the loss and accuracy. Okay, is actually to monitor the model's learning performance. The aim of the loss and accuracy, the loss is to get the lower value for loss and the higher value for accuracy. So in the output, both loss and accuracy are determined for the training and validation for each epoch. Okay, So in this case, for this data, we have 240 data for 80% and 61, because we have three. If you look here, we have how many data? 303. Okay, 303 and 303 rows and 14 column or 14 features, but the features is 13, inclusive of one target. Okay, target. Okay, so based on that, okay, MLP, I will proceed with DL now. Okay, for the DL, normally, when we talk about deep learning, normally, we okay, for the image is very established. It's like established for the image like normal image lah. But if you go for X-ray, for image like NDE, non-destructive images, needs a lot of research there, right? So deep learning is a technique. Okay, two of the popular deep learning methods are convolutional neural network and long short-term memory. Long short-term memory is based on recurrent network. Okay, these are two. Okay, but when we want to implement deep learning, normally we can use deep learning when we deal with big data. Okay, but you need to determine what is the big data actually. Okay, what is the definition of big data? Is it the volume or velocity or variety? Okay, you look at. Okay, and then normally we need GPU, graphical processing unit. Okay, if you use the more powerful computer like GPU, very probably GPU 8030 for instance, then much better. But however, for the student, they usually utilize Google Colabs. Okay, Google Colabs is like Jupyter lah. Okay, Jupyter notebook. When we run Python, normally we use Jupyter, Anaconda Jupyter. But if you want to use GPU, you can use Google Colab. Okay, normally students use Google Colab to run, because some of the when we use deep learning, we need TensorFlow. When we need TensorFlow, we need a more a powerful computer. So we need GPU, right? Okay, this is a convolutional neural network. Okay, it's a bit different compared to MLP just now. In a convolutional network, there are three main layers. Okay, convolution layers, pooling layers, and fully connected layers. Okay, I'm not going to go detail about this, but you need to understand that these two layers, convolutional layers and pooling layers, is the feature extractor. It's like a feature extractor layer. So where we did the training there, okay, is a feature extractor. How the images, or let's say you have images here, so how we perform the feature extraction. So when we perform the feature extraction using these two layers, and then we go for fully connected layers for the as a classifier. So in this case, we use MLP for the fully connected. Okay, so let's go to this example, heart disease. We use the same data, but when normal. I just want to mention that when we use CNN, it is normally for large data set, and it is good for image data set or something like text document, natural language processing. But in this case, I just try using the same data. Using the same data that we have heart disease just now, where we run into MLP. But in this case, we use the same data, but we run the CNN. I just want to show how to put DL, deep learning, which is consists of DL and MLP in this Python code. Okay, so here, if you can see, if you still remember when here is a part of MLP, right? But when we use CNN, we just need to add this row. Okay, these few rows. We need the model. We need to define the model of CNN here. So here, because of the data is 1D, one dimension, then we use 1D here. Okay, input shape the same. We need to understand the input shape. What is the input that are going to be for your network. Okay, so and then you need to add max pooling ID. This is the convolution layer, and then max pooling layer. In the convolution layer, actually there are filter layer. It's been done at the back end. Okay, so here you can see there are two, right? Convolution ID and convolution ID. We use two actually. We call two blocks. Okay, two blocks here. Okay, and then because when we look at the summary of the structure here, so you can see we have one max pooling and two block of convolution, meaning that they perform two times. Okay, after convolution, then they do max pooling, then they use the convolution and then do the max pooling again, and then after that, another part they need to know is the flatten. Why we use flatten? Because of we want to make it flat, because now it is in the because this is 1D, it's okay. Okay, but if you use images, it could be 3D, right? So we want to make it flatten to layman, okay, to make it data like a matrix, okay, a 1D matrix. Okay, so these are the architecture for the CNN, and then of course when we need to compile, okay, we need to compile the model. Okay, when we want to compile the model, normally we put the optimizer there. Okay, in CNN normally we use ADAM. ADAM is a popular. Okay, is a popular. Of course, there are other models, but based on my experience, ADAM is the popular, and when I test with many data, ADAM is perform better. Okay. Okay. So now when we complete defining the model, now step 5 is to training the model. When we train the model, so we need to know the results, right? So we have the accuracy here. Normally, it's a simple. When you get to run this, you will get familiar with this. Okay, you will see the result here. So we look at the accuracy and loss, right? So okay, so now okay, this is as testing. Of course, when we have a model, then we need to test using a real data. Okay, this is example also here. So we use here another data, we call hard data testing. I just make it data available. Okay, try to for the demonstration so that you can see the results here. Okay, so you can see here from the results, prediction output is 1 and true label is 1. This is true lah, because the target, our target is 1, and then the label, the true label, because this is a testing, but in the real life, we are not going to look into the true label. But now for the testing, we want to see it, whether it is correct or not. Okay, so let's look here. Okay, the 1, 2, 3, 4th one. Okay, so the prediction output is 1, the true label is 1 also. Okay, the last one, the prediction output is 1, then true label is 0. So means that this is false actually. This is not correct because the label is 0 but 1. Okay, bear in mind when we perform machine learning or deep learning, there are an accuracy and loss value. So we sometimes it is very hard for us to get 100% accurate. Yeah, it is very hard because it is based on pattern. But if we have more we need to test it. Sometimes we got 90%, 95%, or sometimes even worse 80%. Depends on data. That's why there are more advanced works need to be done, like hyperparameter and many things lah. Hybrid with other algorithms, for instance. Okay, let's move on. I just want to brief a bit about it. Okay, now case study 3 is on an image. Yeah, so here I use the Shenzhen dataset. Shenzhen dataset that I mentioned just now, which has a TB and normal. Okay, the target output is 0, 1, but 0 meant for normal, 1 is meant for TB. Okay, the library is similar. The process are almost similar. Only we need more aspect to look into in terms of the this is more advanced a bit about just now. Okay, so here we need to understand the the convolution. Okay, the convolution. Now we use 2D, convolution 2D. Okay, 3 and 3 is the convolution, how they flip within the from the input pattern. They are flipping the uh, we use kernel, kernel. So the filter or the kernel will do that by 3 by 3, 3 by 3, and they will perform this, and we use the same thing, max spooling, and then do the model, the flatten. Okay, this one we call one block. We can add more block here if you want. We can test and try. Okay. And then we use the same MLP here in the image. Okay, we use the fully connected layers also. Okay, so these are the setting. Okay, and then we compile. Okay, for the SGD is it's okay. It is like optional, but it is good to have, because normally when we train neural network or network or deep learning, we always looking at the learning rates. Okay, how they perform in terms of learning. Okay, right. So these are the the details about the loading. Okay, the training, we have 97 image belong and 50 image. Okay. um Okay, we have a training model results here. The same thing, almost similar. Well, I have, okay, so now here, the most important thing when we train data, we need to monitor. We need to monitor, because sometimes if you look at the graph here, it could be overfitting. Okay, it could be overfitting. Overfitting means they will not improve. Okay, even you see the accuracy is good, but sometimes the loss meaning that it is loss mean is in general terms, it looks like it is not learning, no learning actually, but the accuracy is high, so that's why we need to monitor. Normally we use this graph for monitoring. All right, so um I hope you get the clear picture now, how to implement deep learning. Okay, focus on convolutional neural network and feed forward. Okay, based on the information, the flow that I share just now. Okay, so for the conclusion, um, what I can say is AI brought ML, NDL, machine learning, and deep learning to be more significant achievement in pattern recognitions. Okay, more solutions can be explored and tested for pattern recognition with more advanced methods. Okay, it is a very good for me. Okay, superb tool. Okay, to help us in exploring more data that we have, and various type of data. Okay, I think that's all from me. So if you need more information, you can probably snapshot this code. You can email to me, okay, or you can link with me in LinkedIn, so that if you want notes, okay, this workshop notes, you can email to me, okay, to get it, because this is in ebook. Okay, in ebook, inshallah. I'm going to publish this ebook actually, but give me 1 week, about 1 week to do this. Okay. um okay, I think that's all for the workshop today. So I hope you can knowledge and get idea from now to perform or to work out on pattern recognitions. Okay, so I wish everyone all the best and good luck. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Marina. That was a very insightful talk. Yeah, it actually starts from basic, and we learn a lot about machine learning before Dr. Marina goes into deep learning, and also Dr. Marina give a lot of background information of what is data, what is unstructured data. So I hope that students out there who are slightly familiar with machine learning, this is a good refresher for you. And for those students or whoever that is absolutely new to machine learning, I hope that this talk was useful in helping you understand and help introduce you to the world of machine learning and deep learning. Okay, so there are a few questions here.
Okay.
Let's see. Okay, let's start with this one from someone who is the name Always Learning. Very nice name. Okay, his question is: Is there such a thing as too much data? How do we know what is the best amount of data for each problem?
Okay. I will answer that first. Okay. Um, how do we know? Can you repeat again, Messi?
Yeah, doctor, it's also on the screen. Yeah, but let me read it out again.
Oh, oh,
Uh, oh
I
yeah,
read.
you are sharing your screen. Okay, yeah. Okay,
Yeah,
so
yeah. I can see the question actually.
it's okay.
Can I
Let
stop
me.
the?
You can minimize your presentation, or I can also
Okay.
read out the question again.
Okay. Let me minimize
Okay.
presentation first.
Okay.
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 So
So if you go back to StreamYard,
okay. I need to go to StreamYard, right?
yeah,
Okay.
yeah, that the
Okay.
problem is at the screen. Yeah, is there such a thing as
Okay.
too much data? How do we know what is the best amount of data for each problem?
Okay. Thank you very much for asking question. Okay, this is from Always Learning. Very very nice name. Very nice name. Okay, so looking at the best amount of data for each problems. Okay, based on I will answer based on my experience. Looking at the data, if we look at the simple data like just now hard data, hard data, then we have a label. Then I think about normally 10,000 of data, but it is depend on the problem. You need to test it out. Probably you can start with small data set and look at the results. Okay, look at the result. Looking at the result, you need to look at the accuracy and loss, and then you test it out and get the results. Normally, if we have more data, it is better because when we have more data, then the computer can understand better the patterns. Okay. One more example I can share is when I did a project. I have a project, for instance, project on X-ray images. Okay, X-ray images. What I gain from experience, from there is when looking at the data, sometimes we in a real world problem, data is not balanced. Okay, there is an imbalanced data. So you can get the result. Probably you can just use balanced data. You are not fully utilize all data. However, in real life, you need all data because it is a real life. Okay, let's say I give you example. You want to classify two things. Okay, let's say classify um, something that is common and something that is not common. So when you have a common things, probably the common things, data about common things is very big, right? But when we talk about rare data or not common data, so the amount of data is small. So we need to readjust that. And we can also looking at another solution. Let's say we use one method, okay, to deal with both common and uncommon data. But later, if we found out in real life it is imbalanced, so we need to find out the solution that can cater imbalanced data. Okay, so normally imbalanced data solution will be um, based on my view and experience, it must be a hybrid solution. It must be a hybrid solution. For instance, you can use ensemble, you can hybrid with computational inspired nature inspired solution. Okay, so I hope you get the idea based on the answer. Is it okay? The answer? Always learning?
Yeah, I think always learning. Maybe you can reach out to Dr. Marina if you want to find out more. Uh, yeah. Okay, so let's move on to the next question. Yeah. Uh,
Mhm.
okay, so we have one question from Noor here. Deep learning is a black box technique. How stable is it in making prediction and decisions? Can it be unpredictable? So this is a very good question. It's $1 million
Okay.
question. Yeah. Okay, doctor.
Okay, normal. This is a question that many people always ask. Okay, deep learning is a black box. Yes, it's a black box. We are not. We cannot see actually what is happening inside. Right, neural network also. In general, the initiation of neural network is also black box. So deep learning more deep. Okay, more deep. Complex networks is more complex and more hard to understand, right? Inside. Okay, so the question is how stable is in making prediction. Okay, what I can say, based on my, I will answer based on my experience only. Yeah, so if we use images, okay, normal images like for instance face recognition, images, normal images that like fruits, food, kan, then we train them using enough data, then we can good result, we can get good accuracy. Okay, good accuracy. Because sometimes one of the example in deep learning is we can use the pre-trained weights from the for instance ImageNet, from the ImageNet like VGG19, or other pre-trained weights. So if you use that, and bear in mind when if the data is similar or behave the same as ImageNet weights, I believe you can get good accuracy. But in my case, sometimes in a real case of, for instance, image like X-ray images, because I'm experienced with a lot of with X-ray images. For X-ray images, it's kind of different because probably the features and pattern is different. So we the prediction or decision, sometimes I can say it is predictable, but sometimes when we just run it, let's say we put BGG19 there and run it, probably we get a very low accuracy. But what we need to do to overcome this, we can employ pre-processing techniques. You know, we can employ other optimizer to improvise it. Okay, I hope I answer the questions. If you
Yeah,
need
it's
more
a
further, you can keep in touch with me. Yeah. Okay.
yeah. I think it's a very big topic itself. So yeah,
Yeah.
so I think you have given us a quite a good overview because I
Yeah.
understand that explainable AI it's an entire field by
Yeah.
itself.
Yeah.
So yeah, but anyway, it's a good topic to
Okay.
keep us thinking and keep us exploring in the field of explainable AI.
Yeah.
Okay, there is a question from Anis Suraya, but I believe that one is a little bit technical.
Oh,
Um,
okay.
yeah, it's a little bit technical. Uh,
Okay, I try. I try.
yeah, okay.
If we have a high accuracy, but looking cross entrepreneurs, you mentioned just now decreasing how we should tackle this. We should increase the volume of data. Oh, okay. Um, okay, like this, huh? Okay. I think
Sorry,
we need.
Dr. Marina, just that
Mm,
we have about 2 more minutes, then we will
okay.
take a short break before the next talk. So, yeah, just,
Okay.
yeah,
I'll try
okay,
to answer
2 more minutes.
in 1.5 minutes.
Okay, thanks. Thanks.
Okay. 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 We first of all we need to understand what is high accuracy, what is the loss. Okay, cross entropy loss. Okay. So accuracy is the truth. Okay, when we have the prediction data, it is true. How much is true, right? And then loss is actually we need to zero loss, because we want to ensure that all data, all the apa outcome, when we get the outcome is low. Okay, we need to ensure it is low, so that if it is if the loss increase, let's say high accuracy is increased and loss increase, there must be something happen, because it should be that loss will be reduced. The value of loss need to be reduced. It is good, but here please consider that this is like two objectives that we want to achieve, either accuracy or loss. But normally what I did is I will find out during the training, I will capture the best loss model. Okay, we can do two actually. We can come up with best loss model, and also we can come up with best final model. There are two things. This one we need to go for the details lah, if you want to know more, because we can setting in the algorithm to make best best loss model, because kita tak nak, we don't want loss value to be high. Okay, so that's all, Messi.
Yeah, thanks,
1.5.
Dr. Marina. So for Anis and for other students or other person joining this call who would like to find out more, you can check out Dr. Marina's book the ebook that's soon to be released, and
Yeah.
you can also keep in touch with Dr. Marina if you have any questions. The slides we will share the slides later. So you can also watch back the video if you want to, revisit some of the points. So yeah, you can also reach out to us if you need more information. Okay, so with that, I'd like to thank Dr. Marina for her time and for bringing us through 1.5 hours of machine learning, deep learning, and data and data analytics in general. So thank you, Dr. Marina, for your time.
Yeah, welcome. All the best, everyone.
Yeah,
Bye.
thanks. Bye. We will have a 5-minute break before we go to the next talk. So we will resume back again at 10:45. Okay, so this is a short break.
Sekali genggam api menjadi bara, semangat tidak bergoyang, teguhkan ikatan yang tersimpul sekian lama. Gunung didaki, gelora dituruni, segera melangkah gagah seiring
Okay, so now it's 10:45. We will continue with our day 4 activity for the Women in AI Summit, co-organized with UTeM. So up next, we have Y talk number 6. The talk is entitled Palm Oil Biotechnology, Breaking Barriers, Creating Opportunities. It's to question to the tech team. It's is Dr. Raviga already in the call? Uh, if not, can you please add her in?
I am. I am
Okay.
on call. I
Yes.
am.
Okay, great. Now I can see you now. Okay. Let me just quickly introduce Dr. Raviga. Yeah. Her full name is Dr. Raviga Devi Sambantanmurthy. Sorry if I mispronounced that. She's a fellow of the Academy of Sciences Malaysia, member of Mensa, and founding and council member of the Malaysian Invention and Design Society. She's a research consultant with the Malaysian Palm Oil Board. Okay, so yeah, speaking of women in science, women in STEM, Dr. Raviga, it's one that we can emulate, yeah, fully women in science, and also all the other women speakers as well. Okay, so this talk will be basically on palm oil, how technology and AI can be used in the industry. So specifically in this talk, it will be on palm oil. So without further ado, I'll pass the time to Dr. Raviga.
Thank you very much, Madam Chair, and a very good morning to everybody, and happy Malaysia Day. It's indeed a pleasure being here today, and I would like to thank the organizing committee for inviting me to share with you insights into navigating challenges and creating opportunities in the oil palm landscape using biotechnology tools. Right? I'd just like to say offhand that my talk is not going to be on AI, but on biotechnology and also commercialization and its use in the industry. Yeah. Now, biotechnology, as its name implies, is an alliance of biology and technology. It is an interface of applied and basic sciences, and it uses biological systems, be it whole organisms or parts of organisms, to create value-added products. Now, biotechnology is often thought of as a modern technology, but in fact, it's as old as human civilization and dates back to around 6000 BC, when yeast was first used to produce beer and wine, and bacteria used to make yogurt. So, biotechnology as we know it today is actually a rebranded version of an age old technology. Biotechnology is very wide and it's often symbolized by 4 different colors. Blue technology for its application in marine and aquatic systems, green biotech for its use in agricultural systems, red for medical and pharmaceutical industries, and white biotechnology refers to its use in industrial processes. And in my talk today, I will be concentrating on green biotechnology as well as the white biotechnology. Now, for those students here, there's huge career opportunities in biotechnology, similar to artificial intelligence. In fact, there are many parallels between biotechnology and artificial intelligence, mainly because of the explosion of data and the tremendous amount of data generation and data management in both fields. And biotechnology definitely requires AI. Okay. Now, the areas that you could go in if you specialize in biotechnology are research and development, operations and manufacturing, quality assurance and regulatory affairs, sales and support, diagnostics. And since biotechnology, like AI, is at the cutting edge of science, there's a lot of generation of new data which needs to be protected. And therefore, IP protection, and there's a space for people to work as patent agents, right? There's also product marketing, and bioinformatics is core. Actually, it's very, very important for biotechnology because there is so much of data generated that needs to be managed as well as analyzed. Now, the Green Revolution witnessed a huge increase in production, in agricultural production, in fact, worldwide because of the use of superior technologies. These include new breeds of high-yielding crops, application of pesticides and fertilizers, controlled water supply or irrigation. A very important breakthrough of the 20th century was the cracking of the genetic code by Watson and Crick that led to the development of tools to probe molecules of life with incredible precision. Therefore, the Green Revolution that catalyzed a quantum leap in productivity evolved into the Gene Revolution, or the New Green Revolution, with promise of increased productivity, sustainability, and economic revitalization. This is especially important in countries like Malaysia, where agriculture and plantation industries are the major economic drivers. Now, for those of you who are not familiar with the oil palm, it is the most productive oil crop in the world, and it outperforms its closest competitor, soybean, by about tenfold. The oil palm contributes to about 43% of the world's edible oil, but it's only planted on about 5% of the land occupied by oil crops. It is thus amazingly productive, but in spite of its productivity, the oil palm industry faces several challenges, chief of which are shortage of labor, shrinking availability of land, and increasing global pressure to increase its sustainability and decrease its environmental footprint. And biotechnology, we realize from the start, can offer solutions to several of these challenges. Now, as I mentioned earlier, the cracking of the genetic code ushered in the new Green Revolution, and it led to the application of agricultural genomics in livestock and crops, and this included the oil palm. Now, we talk a lot about genomics. What is genomics? It is the study and the application of information on the genome. The genome is the genetic blueprint of life. The genome contains your complete set of genetic information, that is, the entire set of genes responsible for every trait, be it the color or shape of your eyes, or your type of hair, your color of your hair, or even whether you can roll your tongue. These are all genetically coded. And genes are coded in DNA molecules, which are packaged into chromosomes. The DNA alphabet comprises only 4 letters or bases, A, C, T, and G, for adenine, cytosine, thymine, and guanine. The sequence of these 4 bases or letters in different combinations, in the billions, in the millions, is actually what your genome is all about. The human genome comprises 23 pairs of these bases, 23 pairs of chromosomes, and the oil palm genome comprises 16 pairs of chromosomes. Okay? Now, the oil palm genome has a size of 1.8 billion base pairs. That means it's got 1.8 billion of these bases or letters. But the genes itself code for only 5% of its genome. The rest is what was loosely referred to in the past as junk DNA. But believe me, there is nothing junk about the remaining 95%. They do have important roles. Now, we wanted to unravel the oil palm genome, find out its sequence, right? And to do this, and because all genomes are large size, well, varying sizes, so the trick to unraveling or sequencing the genome is to first break them up into small pieces. After having broken them into small pieces, you sequence the individual small pieces and then put them all back together or assemble them back to get your genome. A very simple analogy would be a jigsaw puzzle. If this is your genome, okay, break it up into pieces and sequence each of these, after which you assemble it back. It's all very okay if the genome is simple, but not so in the case of the oil palm. There were many pieces that looked identical, very similar. As I mentioned, only 5% was genes, it's 95% of junk DNA. And these have got repeating sequences that are all similar. So putting it back was indeed a challenge. It was really like a gigantic jigsaw puzzle. But using various algorithms and strategies, we did manage to sequence and assemble the all palm genome. As I mentioned, it's got 1.8 gigabases, and we discovered that it has got more than 38,000 genes. And having got the genome sequence, we are now mining it for important economic traits. Not only are we at MPOB mining it, we have shared the sequence. We are the first organization in the world to have shared its sequence with the scientific community. And so this is the first reference genome of the old palm. Here I mentioned that there are 16 chromosomes. The 16 chromosomes are represented here in a circular plot known as a circos plot. Already we have discovered 3 important genes of economic value. That is the shell gene, fruit color gene, and the gene controlling clonal abnormality. First, the shell gene. Why were we interested in the shell gene? It's because the shell gene is one of the most important determinants of oil yield. If you look at this picture here, this is known as a tenera. The oil palm has 3 different fruit forms. The tenera fruit form, where the shell is thin. And because the shell is thin, it therefore has got more fleshy mesocarp and therefore more oil. For the information of those who are not too familiar with the oil palm produces 2 types of oil. The mesocarp oil that we know as palm oil, and what's inside is kernel oil, which is more similar to coconut oil. So palm oil, as we know it, is this mesocarp oil. Now the dura fruit form has got a very thick shell and therefore less fruit pulp and therefore less oil. The Piscifera has got no shell at all. So you would think that this would be the best form to plant, but no. The tenera is the commercial planting material in all of Southeast Asia. The reason for this is that the Piscifera, although it has got no shell, is female infertile. That means it does not produce fruit, and therefore most of the time it does not produce any oil. The tenera, therefore, is the preferred variety for commercial planting. It has got 30% more oil than the dura and 100% more oil than the Piscifera. Now, although tenera is the commercial planting material, there is contamination in the fields. And this contamination with dura and Piscifera leads to revenue loss in the billions for the country. So we were very interested in discovering the shell gene. And indeed, we did discover the shell gene. And our discovery of the shell gene, as well as our sequencing of the all palm genome, was published in 2 back-to-back publications in Nature. And our achievement was carried out in the local and in the international press. And most of you will probably know that palm oil gets a lot of flack from the international press. But with the sequencing and discovery of the shell gene, we received a lot of positive press. We were featured in the New York Times, BBC, The Guardian, all of them, International Business Times, all gave very positive comments on what we had done. And I know all of you know Harrison Ford. Well, Harrison Ford, but you may not know, is a very big critic of the oil palm industry. So Scientific American interviewed Harrison Ford and me over the phone. And it was really great for Harrison Ford, and this was published in Scientific American, where he actually was very positive about the work that we had done and our discoveries on the genome. So basically, I'm trying to say here is that you can actually change minds with good data and good science. Okay? Now, I mentioned earlier about contamination leading to billions of ringgit loss. The reason for this is prior to our discovery of the shell gene, the only way we could know what kind of fruit the palm was really producing was to first plant it, wait for it for 3 to 4 years to bear fruit, and then after harvesting the bunch, you cut the fruit into, and you look at the cross sections. And based on the cross sections, you would know whether you've got a tenera, which is what you want, or you've got contamination with dura or piscifera. Now, by the time you do this, you can see the palm is already very tall, and uprooting it is actually not a possibility. So you have to live with the dura and piscifera contamination. And this is especially serious if you consider the fact that we are not talking about a plant like soybean, which is harvested every year and planted. You're talking about the oil palm, which has an economic lifespan of 25 years or more. So if you've got dura there, you've got it in the field giving lower oil or no oil in the case of piscifera for the next 25 years. So you can imagine how important that discovery of the shell gene was, because with the shell gene, we no longer need to do this, but we developed a DNA test kit based on our sequence of the identification of the shell gene. So now all we have to do is extract DNA. You can have a choice. You could either extract it from the seed, or you could go to the nursery in case you've already got plants in the nursery. Go to the nursery, extract DNA, and then you analyze it. And this is a simple PCR explanation. If it is dura in this case, you've got 2 bags, tenera 3, piscifera 1. So very early on, you know what you're going to get, and therefore you can exclusively germinate tenera seeds or exclusively plant tenera seedlings with almost 100% no contamination. And that's a huge improvement for the industry. I just want to give an example here. See, the oil palm industry is very highly regulated, and there are cerium standards for its quality. So there's a cerium standard, MS157, for the allowable contamination with non-tenera, means dura or piscifera, okay? And it is 5% or less. Now, the oil palm industry all along has been very confident and insisting that its contamination with non-tenera is less than 5%. However, DNA tests don't lie. We measured over 1 million palms across the country and discovered that the average national contamination with non-tenera was 9 to 12%. And that means a loss of about 3.5 billion per year in oil production. Seen the other way, what we are saying is that if you now make screening compulsory, then the country, the oil palm industry, would see an increase of 3.5 billion a year, and the GNI of the country would now be 5.4 BNI in gains. That's a huge gain for the country with biotechnology too. After having discovered the shell gene, our next target was the fruit color gene. The reason we were interested in the fruit color gene is that because it controls, obviously, fruit color, and therefore an important indicator of fruit ripeness. The commonly planted variety is the nigrescens, and there's very little difference in the nigrescens when it's unripe or ripe, especially if you consider the harvester is standing at the bottom of the tree, and the part the harvester sees is this part, not this part. So looks alike, and so very difficult to say whether whether the bunch is really ripe. However, there's another variety known as virescens, which has a dramatic change in color from unripe to ripe. And there are several agencies that are interested in planting virescens simply because it's easier to know when it's ripe. And of course, ripeness is again associated with oil yield. So we have also developed a diagnostic kit similar to the shell gene, where you can extract the DNA and know at the seed stage or at the nursery plant stage whether you have got a nigrescens or virescens. And this too, like the shell DNA test, this too has been commercialized. We are calling our DNA test, they've all got the name Sure Savit to show that, well, you're sure what you're planting, yeah? So this is a Sure Savit DNA test. And this was published in Nature Communication. Now, tissue culture. Tissue culture is a very promising technology because it allows for the mass propagation of thousands or millions of genetic copies, right, of a superior plant, right? Once you identify a superior yielding plant, then you can clone or tissue culture it, and therefore you can have genetic copies, genetic carbon copies of the high yielding palm. And this would have a potential increase to the industry of about 20 to 30%. I mentioned earlier that the Tenera gives you about 30% more oil. Here I'm talking about an additional 25 to 30% over and above what the Tenera can give, because here you're only going to plant the material that's very high yielding. So there was a lot of excitement in the 80s. However, this excitement was dashed in 1986 with the emergence of clonal or tissue culture abnormality. There were different types of abnormality in tissue culture material or clonal material, the most serious of which was the mantled abnormality. It's called mantled because, as you can see, it's got a whorl or a layer, surrounding layer, or a cloak around it like a mantle. So this is called the mantled variety, and it results in huge losses in oil yield because the fruits just rot, right? They do not ripen, and there is bunch failure, right? So they do not. So obviously the oil palm industry was very, very upset, and they were looking for an answer to what was causing this. With a lot of research worldwide in Malaysia, the Malaysian Palm Oil Board, we had established that this was not a genetic phenomenon, but an epigenetic phenomenon. Now, what is an epigenetic phenomenon? Epigenetic phenomena is a change in the epigenome. What is the epigenome? Now, earlier I talked about the genome, which is the sequence. This is your genetic code. So the genome is often known as the first code. I mentioned to you, you've got this sequence of 4 bases. So that is your first code. But it was more recently discovered that in addition to this first code, there is a second code where you've got tags on top of this first code. There are different types of tags, but the most common chemical tag is this methyl group. These tags act as molecular switches. A very simple example I'd like to give you is the honeybee. Right? Whether a honeybee becomes a queen bee or is a worker bee depends on its epigenome. And the epigenome is controlled by the environment as well as nutrition, which is part of the environment. Yeah, what the food you eat is also your environment. So the queen bee gets royal jelly, while the others get pollen and honey. And because of that difference, there's a change in the epigenome, and therefore you can either have a queen bee or a worker bee or what have you. So we knew that as far as the oil palm mantle abnormality was concerned, it was also a change in the methylation. There was some kind of molecular switch being caused by methylation, but we did not know which gene this methylation was affecting. So since we had already sequenced the genome, we used this as a reference point, and we studied the DNA methylation across the entire genome. And to do this, we looked at the epigenome of 180 clonal palms, which represented the diversity of clonal oil palm across Malaysia. If you can look at this Venn diagram here, the different clonal palms, they all have got different molecular or epigenetic tags. There are thousands of methylation marks which are different between abnormal and normal. But we wanted to see one that all agencies that produce clonal material, or all agencies that contributed to this work, we wanted to find that one gene that all had in common, because that would be the gene controlling abnormality. And believe it or not, out of these thousands from the different agencies, we actually managed to pinpoint that's one gene, right? And so we pinpointed the causative DNA methylation. Right? We discovered actually that it was a DNA methylation change in a gene, a flowering related gene in the oil palm known as deficiency. What was happening was in this gene, a retrotransposon, you can think of it as junk DNA. There was a junk DNA inserted in this gene. As long as this junk DNA or retrotransposon had dense methylation, lots of methylation marks, then you got a normal fruit. However, if there was a hypomethylation or no methylation, then what it did was it switched the abnormality, right? So we discovered that it was karma, right? The retrotransposon was called karma. So if it has got good methylation, we called it good karma. And if it was no methylation or low methylation, then it's bad karma, giving rise to clonal abnormality. This discovery earned us a place in the front cover of Nature, and it's very aptly titled Weed Out Bad Karma, the epigenetic trait that can ruin an oil palm crop. The discovery of mantle obviously will help us transform the tissue culture industry, right, by weeding out bad karma and planting good karma. And more importantly, it can transform the whole oil palm industry because we can now plant clones with confidence. Prior to this, the industry was not confident. Well, most of industry was not confident to plant clonal material. Number one, they were expensive. Number two, it took a long time, more than 6 years to produce the clones. And it's really heartbreaking if after all those years, you check in your field and you've got these M's here which are mantled. Now, fortunately, now that we have discovered the underlying cause of this clonal abnormality, we have developed a diagnostic kit called Sure Solid Karma, for which we can now, before planting in the field, know with high level of confidence that we will be only getting normal clonal palms. Now this slide, in a way, summarizes our oil palm genome program. So we've managed to sequence and assemble the oil palm genome. We discovered important traits, genes controlling traits of interest, from the shell gene to the fruit color gene, and then karma in the deficiency genes. We've got 3 publications in Nature, 1 in Nature Communication, and we have commercialized all of these, right? And that covers the genome program, which is the green biotechnology I referred to, right? I would now like to move on to white biotechnology or industrial biotechnology. And I will talk to you about the discovery and the extraction of palm phenolics from bio-waste. Now, the oil palm, as you mostly know, the main economic product from the oil palm is palm oil. Now, the non-oil components after palm oil processing, being water-soluble, enter the aqueous waste stream and are discarded as palm oil mill effluent. Malaysia alone produces about 58 million tons of palm oil mill effluent, and this can be an environmental burden, but the Department of Environment in Malaysia is very strict and has got very stringent regulations for disposal of palm oil mill effluent. But this adds, of course, cost. And it occurred to us that while we are so fixated on the oil, we have actually lost sight of the fact that the oil palm is actually a very colorful fruit. In fact, it's a beautifully colored fruit. And colored fruits are usually associated with excellent health-giving properties, just like the strawberries, the berries, the blueberries. They are all now regarded as superfruits. And the component that gives them their superfruit status is actually phenolics. It's phenolics that gives them that bright coloring, right? And very good bioactive properties. Now, the oil palm, we realized then, is also a very, very colorful fruit. And it must be rich in phenolics. And then it just occurred to us that these phenolics, being water-soluble, are all literally being washed down the drain. Right? So we checked and so we suddenly realized that instead of being a problem, we could actually turn these 58 million tons of palm oil mill effluent, or at least some of it, into an opportunity. Right? We looked for the components, and indeed it had 2.4%, which is a heck of a lot considering you've got about 58 million tons of palm oil mill effluent in the country. There were other nutrients, but we were especially interested in the phenolics, as we know that phenolics have got good bioactive properties. We developed a simple solvent-free process for extracting the phenolics. I just want to say we did not allow it to go into the effluent, but what we did was, during the milling process, the aqueous stream was channeled into our process. We built a pilot plant in Labu, Negeri Sembilan, I beg your pardon. Okay? And this shows the oil palm phenolics we produce. As I mentioned, polyphenols or phenolics are associated with a lot of bioactivities, not just from oil palm, but from other fruits like berries, pomegranate. So we looked at the whole range of these bioactivities using either in vitro or cell culture or whole animal or even microarray studies. Microarray, in simple language, refers to a DNA chip. Okay? And we found that oil palm phenolics have got a whole gamut of bioactivities, from antioxidant, anti-diabetic, anti-cancer, anti-hypertensive, anti-atherogenic. The list goes on. We especially like to comment on anti-inflammatory because there is increasing evidence now that many of the degenerative conditions, including aging, diabetes, cancer, atherogenesis, they all actually are because of chronic inflammation. Not acute, but a chronic inflammation that's there all the time and that increases as you age. So the anti-inflammatory is actually very important because if it's anti-inflammatory, chances are you're going to get improvement in all the other conditions as well. We have got about 31 patents for our discoveries on the oil palm phenolics and several publications in peer-reviewed journals. I'm not going to go through all these properties, but maybe just show you a few of them. We looked at the superior antioxidant capacity of oil palm phenolics. I would just like to mention here too that all our work, we don't do it alone. We are great believers in collaboration. And this work was done in collaboration with MIT. We compared the antioxidant capacity of oil palm phenolics with other so-called healthy juices, including red wine, cranberry juice, pomegranate juice, which are all very popular these days, acai juice. And the oil palm had significantly higher antioxidant activity than the rest. We also looked at the anti-diabetic properties of oil palm phenolics. This is the Nile rat. It lives along the banks of the River Nile. Now, as long as the Nile rat lives by the Nile River, burrowing, looking for its food, having exercise, and feeding on grass and grain, it was fine. But when you bring it to the lab, like we did, give it good food, then it develops all the conditions of metabolic syndrome. Pretty much very similar to what's happening to mankind. We have a sedentary life, good food, and getting more and more metabolic syndrome cases. This is the Nile rat in the lab, right? It has got high glucose levels. But after 17 weeks in this particular experiment, after 17 weeks of feeding it with oil palm phenolics, the sugar level came down considerably, significantly. This too has been published. We also looked at the effect of oil palm phenolics on heart health. And several experiments were done to do this, but I'll just explain a couple of them. In this particular experiment, we fed rabbits an atherogenic diet, high cholesterol diet, right? After the end of the experiment, we sacrificed the rabbits, took out their aorta and examined them. And a picture paints 1,000 words. You can see this, the rabbits that were given an atherogenic diet with high cholesterol. And you can see the aorta was pretty much blocked. When they were given phenolics, it was much, much cleaner aorta. And very nicely, if you give them a combination of phenolics and vitamin E, a specific type of vitamin E we get in palm oil known as tocotrienol, we found that it was an even better effect, showing the the all palm phenolics work synergistically to even further reduce atherogenesis. These results are actually shown in this graph. Atherogenesis progresses from starting with a fatty streak, and then it goes on to a fatty plaque, and a fibrous plaque is when the vessel gets blocked up badly. So you can see in all these cases, the all palm phenolics reduces fatty streak, reduces fatty plaque, as well as fibrous plaque, showing that it will obviously improve heart health, at least in this animal model. In another model where we use rats, we chemically induced blood pressure, right? So this is a normal rat, blood pressure is normal, but we could chemically induce blood pressure and the BP goes up. However, if we gave phenolics to these chemically induced rats with high blood pressure, the phenolics significantly brought down the blood pressure. So it improves cardiovascular health in different mechanisms, one by reducing atherogenesis, the other by controlling blood pressure, right? So it's really interesting. We also wanted to see what effect it had on gene expression. That means what's its effect at the molecular level. For this, we carried out gene expression studies. I will not go into the details of how we carried this, but suffice to mention that we discovered that several antioxidant genes were upregulated, meaning that the activity was increased when given all palm phenolics, indicating that all palm phenolics provides high antioxidant defense in the heart, which is prone to damage by pro-oxidants. We also found that, and we were really pleased with this finding, we found that all palm phenolics elicited gene expression effects very similar to the effects of caloric restriction. That is, all palm phenolics act as a caloric restriction mimetic. It is mimicking the effects of caloric restriction. I think most of us here know that the most robust means of extending lifespan, and this has been shown in a whole range of organisms, from the worm to the monkey, is that the only, in fact, robust way of extending lifespan is by caloric restriction, meaning you simply have to restrict your calories. Or perhaps you can have your cake and eat it, but have phenolics with it, since it's acting as a mimetic, restriction mimetic. Let me just show this to you. Allow me to introduce you to Owen and Eeyore. Both of them were about 27 years when this was published in Science. Owen was given a normal diet for 20 years, whereas Eeyore was given a caloric restricted diet. And you can pretty much see the huge difference in these two monkeys simply because of a restriction in calories. So we were just very interested, since we discovered that all palm phenolics acts as a caloric mimetic. Could we see whether it increases lifespan? We were not prepared to wait for 20 years. I don't have 20 years, by the way. So we used the fruit fly as a model. And we either gave it a standard diet that fruit flies get, or we gave them phenolics. And this is these are flies that were on the normal diet. You can see that almost all of them were dead by 70 days. And at all stages, there were a lot more surviving flies which had all palm phenolics. The different colors are actually, this one is all palm phenolics. These are two different fractions of all palm phenolics. In all cases, much higher survival rate than with the control. And you can see that all of them, the life expectancy or the survival extended to day 90. I mean, a 20-day increase in survival is a lot for an animal whose maximum survival is about 70 days. Now, increase in lifespan. So great if you keep on increasing lifespan, and that is happening on a worldwide level, right? Especially women. Life expectancy is increasing. However, along with the life expectancy, we also have an increase of neurodegenerative diseases, the most serious of which, or the most prevalent of which, are Alzheimer's disease and Parkinson's. So it's no point living longer if it's going to be such a burden, because having these neurodegenerative diseases has got economic and social implications, increased healthcare costs, and of course, reduce quality of life. So we wanted to see the effect of all palm phenolics on cognitive health. In this experiment with a water maze, we tracked the mice and how long it took for these mice to reach the platform. We threw the mice in the water maze and we tracked how long it took for them to reach the platform. I'm not sure if you can see the platform in here, but there's a platform here. And we found that mice that were on all palm phenolics reached the platform significantly faster than control mice which had normal mouse chow without phenolics. We thought that perhaps the mice with phenolics had grown stronger and were swimming faster, but that was not the case. The velocity of the swimming was not significantly different. What was different, however, was that the mice on phenolics took a shorter distance, meaning they found the shortcut and learned it and remembered it. So we concluded that the phenolics results in better cognitive function and spatial learning. We also looked at gene expression as we did for the heart, and what we found was an upregulation of genes involved in brain development activity and a downregulation of genes involved in inflammation. Now, another reason for neurodegeneration is actually neurotoxins in the brain. Now, one of the most common proteins in the neuron is alpha-synuclein. Now, alpha-synuclein is normally found around the plasma membrane, and it is an important component of neurons. However, misfolding and aggregation of alpha-synuclein is a hallmark of neurodegenerative diseases like Parkinson's. Okay? So in this experiment, these are the control cells. You can see that they are aggregating within the cells. However, when there was in the presence of phenolics, and these are different concentrations of phenolics, the alpha-synuclein is seen around, right? It's integrating within the cell membrane and it is not integrating. So very much similar to the normal process of alpha-synuclein. So what are the triggers for neurodegenerative diseases? Oxidative stress for sure, inflammation, neurotoxins, and reduced blood flow. Okay? And phenolics, we have shown that it has got superior antioxidant properties. I did not show the data, but we have very strong data, which has been patented as well, that it has got potent anti-inflammatory effects. The work on the alpha-synuclein showed that it protects against neurotoxins. The work on cardiovascular function showed that it also improves blood flow, which is important for neurological health, right? So the mechanisms by which phenolics protects against neurodegeneration are multifaceted, right? So we've had several awards, I would say awards. The most important one, I think, is we are the only Malaysians who've ever been conferred as Tech Museum laureates. We were featured in the Washington Press. I especially like what they said about the thinkers. We were known as the thinkers, or they called us the influential thinkers. And the first sentence says it all. Influence can flow from the power of money or the power of ideas. And what we are talking about today, not just my presentation, but all the presentations across the week, it's all about ideas. And that's what is really important, more important than money. That's it. Now, the phenolics market, having said that, money is important. So the phenolics market is expected to reach USD 2.08 billion by 2025, right? It's a rapidly growing market, and it's the growth drivers are increasing health and wellness concerns, increasing scientific evidence supporting health foods, rising disposable incomes, especially from the young, and a growing beauty fixation. Right? So, since we were very confident that our work on the phenolics had definite health, economic, and environmental impacts, we were pretty sure that commercializing it would be easy peasy. But that was not the case. And we were pretty much in the situation in this cartoon. This really is an innovative approach, but I'm afraid we can't consider it. It's never been done before. The industry was very risk averse and did not want to invest in a technology that is kind of expensive. So we finally found a taker, Phenolics Technology. And Phenolics Technology, Sendiri and Rahat actually looked for investors in Malaysia, but failing to find investors in Malaysia, then it reached out. And now, very happily, I'm to say that the world's first phenolics production plant actually is in Mexico. This is the world's first phenolics production plant. It was taken in 2019 when I was invited for the opening. And the first batch of commercial products on phenolics, trademarked palm fruit bioactive, was rolled out, was rolled out as a bulk ingredient in the US in June 2019 for worldwide distribution. And Amare Global, a leading mental wellness company in USA, launched the first product formulated with all palm phenolics, trademarked Menta Heart. Okay? So can the palm oil industry also be a global supplier of natural antioxidants and bioactives? I think yes. Before I finish, I'd like to acknowledge many people. I would just like to say that this is not a one-man show or a two-man show. It's all team effort. MPOB strongly believes that science cannot thrive in isolation. And we work with different people in different parts of the world, including Malaysia. I would like very much to acknowledge the current Director General of MPOB, Dr. Ahmad Parvez. He has been absolutely supportive of both the Genome Project as well as the Phenolics Project. Dr. Arif Manaf, also the Director of the Advanced Biotechnology and Breeding Center, where all the genome work took place. In fact, all the phenolics work that I described are also done at ABBC. Puan Rosida, the Director of Product Development and Advisory Services, because advisory services is obviously important for products, and the phenolics work is now being carried out at PADAS. And unlike perhaps chemistry, biology or genome work is a long-term venture. It's not something that can be done in a year or two. So the work actually took root. The genome work actually took root during the time of Dr. Muhammad Basri when he was the Director General. So did the phenolics work, and he was extremely supportive of both programs, as was Dr. Chu Yun Mei. And now our very highly visionary Director General is very, very supportive and proud of MPOB achievements. Now, this is the genome team. Okay? This is an amazing group of people. This is Dr. Rajinder Singh. He is the head of unit of genomics unit. Right? Now, two of the Nature papers were with Dr. Rajinder as the first author. He's really a very, very talented scientist. Right? And here is, yes, that's Dr. Arif Manaf, the director of ABBC. Dr. Melina Ong, she is the head of the tissue culture unit and very much involved in tissue culture work. And the Nature paper on karma was with Dr. Melina as the first author. And this is Dr. Leslie Lau. He is the head of the bioinformatics unit, a very core component of the biotechnology. And these are the rest of this fantastic, amazing team. We work, as I said, in collaboration. Our discoveries were in collaboration with Orion Genomics, a US company. And these are the team members of Orion Genomics. Then Nathan Lakey is the CEO of Orion Genomics. And again, a fantastic team to work with. Here we've got Nathan again. As I said, he's the CEO and also a founder of Orion Genomics. And this is Professor Rob Martinson, a world-renowned plant development scientist and epigeneticist. He too is a co-founder of Orion Genomics. This is the amazing genome team. And this is the phenolics team. We work with MIT, Brandeis, Brigham and Women's Hospital, CSIRO, and Phenolics. The idea for phenolics actually started with a coffee break between me and my buddies, Dr. Tan WAI and Dr. Kalyana Sundaram, now Dato. And just to tell you how important it is to relax, we got this idea over a coffee break. So important is you can't always be working. You need to relax for the mind to think ideas. We now have Dr. Said Fairuz working on phenolics, Dr. Liao Sun Sen. Actually, many of the projects I described were actually done by Liao Sun Sen for the phenolics work. And there's Anisha, she worked on, what did she work on? She worked on
Sorry, Dr. Raviga.
Yeah.
Sorry, Dr. Raviga, to interrupt you there. Just a time check. Yeah, we have
Yeah.
about 4 minutes, 4 minutes plus or so left. So maybe we open to Q&A. Yeah, because we just want to make sure that you can take some questions. Yeah. Okay. So maybe I'll start with myself. Yeah, I do have some one or two questions.
Let me close my
sure.
slide so that I don't have to. I can stop sharing, right? So I can see.
Can.
Yeah.
Okay. So first of all, I think I'm very, very impressed with your research work, and it's such an illustrious research career you have there. Not many people can boast that they can publish in Nature journal. So it's as a researcher myself, it will be my dream to be able to publish in Nature. So it's absolutely amazing that you have achieved that, and also appearing in Nature cover. So that's really, really great. And then you're such a great role model to all the women out there who wants to establish a career in STEM. So my question to you is that you are so big in palm oil research. Is there any area that you think AI can bring more value to your work? So just to give you some example of application of AI. So there are drone technologies now to survey vast lands. So it can be used to survey, palm oil estate instead of sending humans to inspect. So these drones can be sort of the eye in the sky that help you monitor. And there are also technologies to grade fruits. Like for example, by just looking at the photo, the computer model is able to tell, okay, what grade is this? Is this grade A, grade B, grade C, and what type of fruit? And this is just some examples. Yeah. So among us, those who are attending this call, we have researchers, we have students who wants to do masters, who wants to do PhD. We have also lecturers in the call. So I just wanted to seek your view. What kind of areas that AI can help you in your research?
No, absolutely. Obviously, in a way, I could say AI is already being used. If you think of handling massive amounts of data, and like we look at gene models, where gene models have training sets, and that's all in a way you can consider that these training sets as employing artificial intelligence, right? In the long, that's a big picture. But another area is, as you say, eye in the sky, whether you got your drones to look for clonal abnormality or Ganoderma infection. Many of these things actually are already being done. So there is a lot of scope for using AI. Another example would be in fruit ripening. Right now, there's no proper standard. Okay, we are fantastic. We're very happy. We've got the gene for fruit color. But once it comes to the mill, it'll be quite nice if you have artificial intelligence to actually see the whole fruit bunch, because the fruit bunch is not one fruit. It's a whole fruit bunch where there are different degrees of ripeness. So these are areas where actually AI would be very useful to actually come up with a model of which is the best ripe stage. Because, we've got registration, we've got regulation. If the fruits are underripe, they are not accepted. But a lot of it is now visual cues, human visual cues. But if you've got AI looking at these, that's one area as well. So there are many areas, actually. I didn't mention it, but I think there are many areas. Yeah. Phenotypic differentiation using AI, yes.
Okay, that's absolutely amazing. So maybe there is some form of collaboration that you can establish with people on this call, especially students who are interested to do a PhD on the topic. Yeah.
I would just like to say that Dr. Rajinder Singh, right? He actually did his MBA at at Sunway, and he is now currently the head of genomics. And there's also Dr. Melina. You can reach out to any of them, but Dr. Rajinder can be your contact point. In fact, it was Dr. Rajinder, I think, who suggested my name for this talk. So you could reach out to Dr. Rajinder. He is an excellent scientist, and so are the other people that I introduced in my acknowledgement. Yeah. So maybe you could go through Dr. Rajinder.
Okay, that's great.
Yeah.
Okay.
Or you could also write to me, not a problem either. I mean, not a problem at all. Yeah. Mm-hmm.
Yeah, sure. We will. We will get hold of your slides and we will share them. So, so it's a very good platform for people who wants to work with you further and to contact you. Just let me quickly look at the question to see if I miss out any good questions. There are There are a lot of comments that says that very impressive work and so on. It's already answered. Yeah. So okay. So let's maybe we can just pause here and so that we can have a break before our next talk. So Dr. Raviga, thank you so much for your talk. We are all very impressed and inspired. So we will definitely keep in touch and we will share your slides with the wider audience. Okay. So
just before I go, thank you very much to the organizing committee, to the technical committee, to make sure everything went without a glitch, and to Dr. Geeta Nadarajan for this invitation as well. Thank you so much.
Thanks. Thank you.
Thank you.
So we will take a break now and we will resume back at 11:45 for the last talk for this morning. Okay, so yeah. Okay, thanks everyone. Welcome back. Now it's 11:45. It's time for our next talk. So before that, just want to wish everyone a happy Malaysia Day and thank you for taking your time to attend this call and join us. So next up, we have WAI talk number 7, entitled Geospatial AI and IR 4.0 for enhancing the output for paddy cultivation. Okay, we are very privileged to have Encik Isma Hadi Ismail to be our speaker for today. Okay, let me just very quickly introduce Mr. Isma Hadi. I'm trying to pull out his bio now. Just give me a minute. It's not loading. Just give me a minute. I need to scroll down. Okay, it's not loading. Just give me one more minute. Must be my internet connection. It's not loading the document. Okay. Okay. Apologies, I'm not sure why it's not loading. Encik Isman Sadi, I'm so sorry. I'm not able to pull out your bio.
Okay, all right.
So maybe you can give a brief introduction of yourself. 1,000 apologies. Yeah, so sorry.
All right. Okay. Thank you, Miss MC, and a very good morning to all. Okay, my name is Ismadi Ismail. I'm the CEO of the Space Science System. I think the company we have started it since just last year, 2020. And we actually focus on the space applications and also on the ground application, which is, we call it as space-based solutions. And that's why we, in principle, hybrid the space technology with the ground technology, and that's where we put in drone technology together so that we can come up with the with what we call it the geospatial AI. And I think the project that we have done April this year is the first one for us after we started the company, and I really hope that I can share the work done by our team with all the participants today. And if you have any question later when I start the presentation, so please ask me your questions, and I will try to answer it as good as I can. And also, I think that later participant also can check my email, and if you have anything, you can also email to me. All right. So, Ms. MC, can I start the presentation now?
Yes. Maybe
Okay.
before that, maybe let me quickly just read your bio. Yeah, just as a
Okay. You can put it now. Okay. All right.
Okay.
Please, thank you.
So, Mr. Isma Hadi Ismail is the Chief Executive Officer, the CEO of Space Science Systems Sendirian Berhad since 1st of April. So we really have the right person to come and speak on how to use AI in geospatial technology. Okay. So the company direction, it's setting up, he's in charge of setting up the company direction in space development, geospatial, IoT, and network connectivity. And so he'll be here to give us more insights about how AI can be used in this field. Okay, over to you.
All right, thank you, Ms. MC. All right. I will start with the mission and vision of my company. And of course, I think everybody would like to be a preferred partner and a company for development integrations, because I think I've been doing space systems since 2002. Up to date, it's been 19 years. So now I'm trying not only to focus on the hardware, but I'm more focusing on the integrations and developing the solutions for the terrestrial or for ground works, so that everybody can benefit from the space. I think in Malaysia, we have been trying to put in space, I think, for quite some time, since 1997. But I think as for a company, we have somehow moving a bit backwards. But I think for universities, yes, I think universities have done a good job, and they have been progressing, I think, very well, especially those teams in UTeM, and also the USM. And then, of course, the mission is basically we are trying to offering the innovative technology to the markets. And then we also, at this moment, linking between educational and the industries. So we work with the partner from universities to develop the product, in which I think we are introducing a bit by bit to the market at this moment. Our product, as mentioned by our MC just now, of course, space technology, this is where our grassroots came from. And from there, we start to link to the UAV and payloads. And then I think later you will see why we link UAV to the satellite. And then of course the product from those two will be the geospatial, and of course the IoT will be the supporting what I call the tools to enable these three of above to deliver the function to the market. Just a bit of space technology. I think everybody knows about not everybody knows, but I think most of the university students know that this is the smallest form of the satellite. They are a bit more smaller than this one. But I think the one that been done by our students, our team in UTeM, also UTeM, they call it a CubeSat. You can have with the 1U CubeSat or the 3U CubeSat. So if you, and then as you look at the market at this moment, I think there's so many companies overseas. And if you look at the Bryce Tech report as well, that they are the launch of the small satellite, I think increasing year to year, year by year. So I would say that this new technology, even though I think previously this CubeSat not been focused by the developer, but I think coming another 5 years, 10 years, I think there will be so many developers that will be involved in CubeSat development and launch to the space and orbiting the Earth, and will be come up with so many payload, I would say, that can benefit the mankind, right? So what is CubeSat? We have, as mentioned just now, different size of the CubeSat. We can have the 1U, we can have the 3U, or we can have the 6U, we can have the 12U. So what makes the difference is basically the size of the CubeSat. And then towards the end, you can have even 36U, or you can put in more payload, more batteries, more modules, so that the satellite can do many things. But please be aware that the problem with the satellite is the power, because this is only have a small solar panel and only a small battery. So if you keep recharging, the debt charging will be too much, and then I think your satellite will be facing a power consumption later on. So like this 1U or 3U, I think normal mission will be about 6 months to a year, and then for 12U and 36U can up to 3 years or more, right? So available platform, this is another platform that I think if everybody might be what I call it familiar to or been listened to the space to the LEO or low Earth orbit constellations called Starlink by SpaceX, owned by Elon Musk. So this is another platform that can do similar things, but it will be creating a different transponder for that purpose, right? Okay, and now I will go a bit of to the UAV. This is the one that we'll be using for our project. We call it the Trinity F90 Plus. It's been manufactured by Quantum System of the Germany. So this is part of the samples that we acquired last time during the project. Okay, this is the flight planning using the Q-based 3D. I think if you realize that what makes the difference between this Trinity is that the flight control software is really comprehensive. It can even give you a fully terrain models. So if you plan your flight planning, you can really have a look at whether there's any interruptions in between your path, because this VTOL or vertical takeoff and landing drones is different from the DJI. If you're familiar to DJI, DJI is basically a multi-copter drones, and it's normally came together with the anti-collisions, but VTOL don't have any anti-collisions, so we need to properly plan for its flight planning, right? So this is some of the results. On the left is the RGB red, green, blue image of the drones, and on the right is basically once we do the processing, we will come up with the digital surface model. Why this DSM? Because we need to do the surface mapping of that certain location, and later why I will show you why we need this for the paddy cultivations. So I think those who involved in remote sensing or in agriculture or in the spectral field would be, I think, has been listening to or has been heard about this NDVI, or the normalized different vegetation index. This is where the scientists or the expert use to identify the crops, to basically monitor because the near infrared and red edge can somehow provide this spectral information of the health of the tree, for example, because it will represent the chlorophyll of the leaf of the crop. So that's where we use to mapping the health of the tree or of the crops, right? So LiDAR is basically is a bit similar to the one that we have at the RGB, but LiDAR, as you know, is another laser ranging detection range. So it will give you a more comprehensive point cloud, so that you can have a better leveling mapping. For paddy, I think the level of your paddy field is very important. Otherwise, it will be going very difficult for you to manage the water of that paddy fields, right? So this is the project that I mentioned just now. We got a project from the Bioeconomy Development Corporation Berhad. This is another GLC, basically under the Ministry of Agriculture and Food Industries. We started the project in March, and we have harvested in August this year. And from this first project, we learned so many things. And then we have tried our algorithm, and later I will show you that the sample of the solutions that we will be enrolled into the market, hopefully in for the next season of this paddy plantation in Malaysia. The location is in the Parit 11 Timur, Sungai Besar in Selangor. So if you have experience coming to Selangor, is more like towards the Sekinchan and Bagan Datuk area, right? So this is where we started the process. We have our drone. We fly the drone over the targeted plots. We have about 68 hectares there in total, and we have about, I think, 31 farmers that involved. So this is the satellite image. We do the plots of the phase 1, phase 2, phase 3, where we do the monitorings, and at the end, actually, we only running all for the phase 1 and phase 2, because for the phase 3, they opted, because we have only one farmers there, so maybe it's not viable to put in just one farmer into the project. So finally, we do for the phase 1 and phase 2. So this is a bit of images of the UAV over the project area. So this is where we capture the image when the drone operator there do the pesticide spraying. As I mentioned just now, that the drone that we have is basically just a tool, and we use the mapping to map the paddy field, the rice, etc. And we later on do the proper mapping of. For example, I will show just later about the pest and disease event happening this year, and it's very bad pest outbreak this year. We've been informed that it's been 8 years that the worst pest outbreak happened in that area, right? So on the left is an NDVI data, as I mentioned just now, and on the right is the RGB or the mosaic data. So we use these two to do the delineations and do the detections of the health of the crops later. Okay, and from there also, beside drone, we also use the spectral radiometer. This is more on the leaf reflectance, because when you fly the drones and at the ground, you still need to do some calibrations, to do some checking, because when you fly the drone is basically captured image scene by scene. So later you need to do the stitching to the software, and then from there you need to do the optimizations of the spectral of the digital numbers, and then from there we use the leaf reflectance, and then also we use the reflectance calibrations on the right, so that you can do the calibration of the drone images load, right? So the step 1 is basically once you do the transplanting, we do the what they call it, the plant density mapping. This is where we need to identify how many trees has been planted for the seasons. Then from there we start monitoring for the next 100 days, because for this breed of the rice, we are planted MRQ 76. The maturity, the ripeness will be in between 150 days, according to our Malaysian Agriculture Research Development Institute, or we call it MARDI. So from there, then we start do the monitoring from day 1 to day 100. All right. So from there, next is top dressing. What is top dressing? So top dressing basically is the stage where we identify what is the appropriate required fertilizer by each plot or by each paddy trees. So this is where the precision farming start coming in, and later, if I think maybe there's some university students that have the interest to do the AI for the paddy cultivations. This is where point that you can come in, because when we talk about top dressing, it will be varies. We call it variable rate treatment to do this. So for the whole plot, it will be different from another area to another area. This is where we trying to minimize the utilizations of the fertilizer. All right. So if you can see here on the left, there's some colors represent the red, a bit green, and the orange. So meaning that for the blue area, you only need to top up just 20 kilos of nitrogen. All right. For the green one is 30 kilos, and the orange one is 40, and then the red one is 50 kilos. So the red one is basically the most unfertilized area. So we need to put in more fertilizer to make it fertilized. So this is where how we come in with the top dressing. So then I think in May, about 19th of May, we have started to oversee a pest outbreak there, and we on the 20th of May, we flown our drone, do the mapping, and then on the left, basically this is the map that we produce. I think we have processed the map everything in 2 days, and then on the 21st, 22nd. We already came up with the pest affected area, and then we delivered the map to the farmers, and then they engage the drone operator, so they start do the pesticide sprayer. So and then on the right, you can see that how the paddy recover from the date of planting 38 to 46 and in 55. So I think through the utilization of this technology, we can see that the what they call it, the effect of the pest outbreak can be minimized. So it is a proven method. So I would like to then we as a company trying to expand our business to other area as well for the second season, right? So this is the pest that we're talking about right now. It's in Malay they call it ulat perebut batang, or in English they call it the stem borer. So it will start attacking the stem of the paddy tree, and then it will start eating the tillers, and then I think then the tillers will die. So at the end, from this outbreak, we have experienced that a losing of 15% of the harvest because of this stem borer. All right. So this is some sample of recovering assessment. If you can see from right to the left, so you can see different colors that show how the greenness of the paddy, and we trying to map it from using the drones, right? So from there, we have identified for the second season that because of we managed to come up with the what they call it detailed maps. So we trying for the second season, we were trying to minimize the utilization of pesticide and also fertilizer. So that's why I think we will start using the dedicated drone for that. So we will have something like as I mentioned just now, we will have something like variable rate treatment. So we will go exactly to the area where affected by the pest, and we will do the pesticide spraying there. So we are not doing whatever the common method, what they call it, been running by the farmers right now, where if anything happened, then they will spray the whole plot. So that it will require a lot of expenses, a lot of pesticide and a lot of fertilizer as well. And then we trying to come up with a better economical agronomy management for the paddy for the second seasons, right? So from our experience of the paddy, we have been talking to market around, and then I think those who doing the chili things asking us if we can come up with the robbers for them. to do the pesticide spraying for the chili. So this is what we are basically developing right now. Is a rover to spray the pesticide from the bottom of the chili leaf, because I think from the top we can using drone. So this is where we're trying to accommodate between drone and the rovers, then to try to what they call it give the best solutions to our clients. All right. So later I think when we have the rovers, we can also upscaling it, that can be used for the oil palm plantation as well. I think our Samdabi plantation is already looking in this matter, and then we also will be trying to what I call it, roll out the same product to the market. All right. If you talk about chili, this is how the spraying will take place. We'll be using a rover from the bottom, and we'll be using the spray drone from the top. So it will be running concurrently. So we can have a better management of the time and better management of the pesticide and the disease of the chili trees. All right. So this is what we have in our lab. We print everything using our 3D printer. So this is how we reduce the what I call it, the operations wise of our resources, and also we can do so many design and so many things with the one that we have, right? All right. For the next season, we already developed our own VTOL drone. We call it the ICA 1. So at this moment, the design will have something like 80 minutes, and radio coverage can go up to 15 kilometers. But at this moment, we focus this drone only for the mapping. So hopefully for the future, we can perhaps expand the function of this drone to some other functions. But at this moment, only for the mapping. So and for us, it will be going to be a bit more cheaper and safer option for. So for this drone, the flight will be 300 to 500 hectare per flight. So I think if we can have a good flight a day, we have a good climate, good weather, good what they call it conditions. Perhaps we can have something like 2,000 hectare per day of coverage of mapping. This is where our humble lab we're doing the development of the drone. We come up with our first prototype. All right. So for the company, for the future plan, we are basically trying to develop and integrate the granule distributing and also the pesticide together in one drone, where you can swap in the tank. And then of course we are trying to do the mapping drone as well. Then we will try to integrate several payload to the drone, so that one drone we can deliver the many inputs that we need for this precision agriculture. And then of course we are also to integrate the ground rover to the drones, and then to roll out to the market as a complete solutions. And at this moment, we are developing a portal for the paddy cultivation management. I will show you later the user interface that we have at this moment, and of course, it will be keep revolutions and changing once as time goes by. And also we also develop and enhance the oil palm plantation management that we have a core right now. So we are basically upgrading and adding more input, so that we can have more output from our oil palm plantation management software. All right. So for the future, I would say that whatever we have done for the first I would say that half is basically on the data collections, and also to test our algorithm, to make sure that whether our algorithm can deliver what we have been designed to it. But for the future, I would say that we need the AI engines to make sure that if now we are talking about 68 hectares, of course we can do everything still manually. But if we talk about 5,000 hectares, 10,000 hectares, and if we talk about the whole Mada area of about 100,000 hectares, there's no way we can fly the drones and we can do the manual processing of it. we need the AI engines that can really support the total operations of the mapping and of the cultivation processes overall. So we do believe that integrating the AI engine to the geospatial will be the best solutions that for us to move to the next millennium. And also we are also to integrate and solutions as a modern precision farmer with IoT, of course, because I think IoT would be another input for the AI engine as well. So we are already what they call it submitting also for the HRDF drone licensing fund from last year, but because of this MCO, I think the process has been delayed a bit. And also we are the next will be our project will be in Kedah. Another I would say that another pilot project. We plan for a signing May, but because of the MCO, I think we need to delay it a bit. And for another states, we have also signed MOU with the top IT industries, one of the GLC Terengganu for drone business expansion there. So we are looking there also for the paddy and also for the oil palm. And the next is to sign MOU with this Tech College Terengganu to focus on the drone pilot license training and also for the certifications. All right. So prelim of the business plan that we have right now. So now world is facing a serious problem in food security. So Malaysia alone, we are spending more than 50 billion to import agriculture product in so many agriculture products. So that's why I think it's about time for a Malaysian company to step in and start not only doing the drones, but also doing the solutions and utilize drone as a tool to do the data collection. This is what we are looking at this moment. So we are planning to come up with what we call it the precision digital agronomy system, the PEDAS. So the PEDAS will have two conventional methods and also the yield compare inside there. So we will have the hardware. Hardware meaning that I think all of you have been familiar with the pH meter, soil meter, data logger, UAS multispectral image, etc. And then the most important will be the software. So this is where the solution will come in. And when we fly the drone, we put in all the data, we put in all the IoT data. From that, it will start the process. It will start to give you recommendations where to put in fertilizer, or where to put in or where to spray the pesticide. So later, I think the software will assist the farmers more efficiently to manage their farms rather than whatever the conventional way they are doing right now. Okay, the system will be, as I mentioned just now, from the left will be the drones, and of course the sensor and then the IoT. So this is where I think all the input will be blended together and to come up with a solid product for farmers. As I mentioned just now, when we talk about a large area, we will talk about 100 hectares. Of course, we can fly the drones, or maybe about 1,000 hectares. We can still fly the drones. But if we talk about 10,000 hectares, we talk about 100,000 hectares. It will be very difficult to what they call it to fly the drones. So we need to use the satellite data. So when you start engage the satellite data, I think the most important is that how for you to calibrate the image from the space to the drones and to the ground. So that is the one that I think will be very, 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 very tough work to do, and there will be a lot of research, a lot of development that I think that the university students can involve in to come up with the fully calibrated product and where we can fully roll out to our farmers. And of course, in this system, we're going to have the online monitoring and reporting. And of course, if we talk about the oil palm, we need to go for the tree countings. And then we go to for the NDVI or NDRE analysis. And then, of course, we need to come up with detailed pest and disease analysis. And of course, the last one will be the field of yield forecasting. So that will be the indicator whether whatever we have done will produce us a good yield or not, will produce a good revenue or not to the company. So as I mentioned just now, when we involve satellite, when we involve drone, when we involve the ground sensor, I think the most important thing is that how to calibrate the soil data from the satellite up to down to ground, and you use the right correction methods, because I think those involved in satellite knows that in between satellite and the Earth surface we have the atmosphere. And as you're aware that if you talk about the high latitude countries like the States or the US, or not the States, the Europeans, or maybe northern part of the China, for the high latitude countries, I think the weather there, the climate there is consistent. Consistent meaning that if you have the clear weather from the 9 o'clock in the morning, maybe up to 4:30 or 5:30 in the evening, you still have a consistent weather. You still have a consistent climate. But if you talk about the equator countries like Malaysia, for example, we have so-called convective rain. Convective rain meaning that the climate is not consistent. You can have a very clear sky from 9 o'clock, for example, to 10, and then suddenly it's a cloudy from 10 to 11, and towards the afternoon from 12 to 2 or 3 p.m. there's a storm. So that's a weather that we are facing right now. So if we really want to have the data between the drones and the satellite, we need to have a fully calibration in between the data between the satellites and the ground. So that's why the atmospheric correction is very, very important if we want to talk about a huge area of data collections and huge area of data management. So we have experience doing it. We got a grant from the government to do this calibration. We call it the cross calibration. We do the calibration between the satellite. We use it airborne and we use drone. So we have a 3-layer of because why we use airborne, because airborne will be flying a bit above the sky, above the cloud, and the drone normally we will fly below the cloud. So we have satellite above the Earth surface, above the atmosphere. We have the airborne above the cloud, and we have a drone below the cloud. So we try to come up with the algorithm to do the corrections of the spectral informations of these solar illuminations, etc., etc. All right. So this is what I'm talking about. On the left, when we do the corrections, we have on the satellite view, we do the corrections. We have the UAV, US view, and then we have the ground view. So the one in the left, the small hemispheric structure there, we call it goniometer. It's been what we call it invented by Prof. Craig Coburn, one of the professors in the Lethbridge University, Canada. So we acquire one system from him, and then we do the what we call it, do the measurement and calibration so that we can do the BRDF, or they call it bi-reflector directional functions. It's where we measure the solar angles and also the solar intensity of the respective time of the respective solar angle. So we can really use it to do the calibration, to do the corrections of the data later on from the satellite or from the drones. All right. So our PDA will later on have something cloud interface proposed like this. So user will be given the username and password. They can go in, they can key in their plot numbers, and then because this we link it using the API from the Google Map. So it's been using WGS84 as the coordinate reference. So you can plug in from any part of the world, as long as it using on the Google Map, you will definitely have accurate map for it. All right. Out of everything, I would say that we were gonna have e-commerce as well on the platform, because if you have the recommended page where people can log in and have a look and have a studies and also get some recommendation what to do to their farmers. And then I think the next will be what will be the how can they fully utilize and use that the platform. So that's why we are also planning to put in inside our e-commerce the fertilizer recommendation and also the pesticide recommendation. So this is where I think another opportunity and chance for fertilizer manufacturer and also for the pesticide manufacturer or reseller to come in and start to advertise their fertilizer and also their pesticide. All right. So a bit of this is what we have in principle, the design. But as I mentioned just now, it will somehow change when we start to roll out. You will have the rice management portal, and in there we will have, if you look at the farmers, information of the farmers, we will have the detailed information of the farmers, historical yield record we will have, because in Malaysia, government giving subsidy to the farmers, and we put in the subsidy there as well, and then we put in number 4 issues. Issues basically whatever the data mining will be done by us of the farmers from maybe last 4 or 5 years. So from there we can know that for example, season 1 is a dry season. So the problem maybe not so much on the virus and on the bacteria. The problem so much on the pesticide. Like I mentioned just now, it's a stem borer. But for the second season, because it's a wet season, so maybe the problem is not on the pest anymore. The problem will be more on the virus and on the bacteria. So we need to have a clear idea what we will be facing for that season, so that we can be ready with our method and also our what they call it, the countermeasure strategy for it. All right. So for the yield forecast, of course, we need to have total areas, and then we need to map the total plantable areas, and then we need to also compare the forecast and actual, and then of course we will produce the report and recommendations. And as for next door, for the GIS farmers, geolocation information system farmer, of course we will have the plot numbers, we have the plot location, name of the plot, performance, disaster report. So this is all the item that we will be putting into our rice management portal for the future, so that our farmer can access. We give them the username and password, and then they can access. And of course, this is another method for us to what they call it, engage a new millennium, a new generation, a young generation, to start giving their interest in farming. So if we keep pushing our young generations to do the old conventional way of doing farming, I would say that we will be facing a very, very serious problem in the future. We were not going to have any young generations interested in doing farming anymore, because young generation, as we aware, they are more the IT savvy, they are more on the gadget like. So we need to suit the what they call it, this cultivations to our generation, so that everybody can contribute and to get what is the best for the nations. And of course, from there, we need to have the stock inventory. We need to have how much fertilizer in your store. We need to have how much pesticide in your store, and then what is the equipment, tools, everything, so to minimize the expenses for these paddy cultivations. And another one, the most important, is basically the crop protection and management. This is normally, if you go to any conference, they will call it pest and disease, P&D. So P&D is very, very important in agronomy or in agriculture, because the effect, if you can't control the pest, you might be losing maybe up to 90%. Because we have experience in our plot for the first season. It's not our plot, but some other plot that been using totally conventional way. I think they have been losing more than 50% of their harvest. So they used to get something like 8 to 10 ton per hectare from the previous year. For this year, they only managed to get 4 ton per hectare. So if we don't really manage this pest and disease, it will really kill the harvest of the paddy or of the rice. Okay, and of course, the most, I think, important in overall will be the yield forecast. So we need to do the yield predictions. I think from our last seasons, we managed to do the yield prediction at the day of 90. So the date of planting 90, we already came up with the forecast. What will be the minimum that to be achieved after we minus the reduction caused by the pest outbreak, and another about 15%. So I would say that if we don't manage the paddy cultivation there using this technology, I think reduction in the yield will be so much more, because I think the pest once it attack, the outbreak when it happened, it will really kill the trees. So you will be losing the yield so much, right? Okay, so another service, because we have we have the data, we have the drones, we have the spectrometer. So if perhaps anybody in the university, for example, that I think the spectrometer, then I think everybody knows, or those who involved in the field knows that how much it will cost you. So I think you can come to us, we can do a discussion, we can do the collaborations. I think we are open for any proposal from universities to use the equipment, to use all the tools that we have, so that we can fully contribute to the universities, and also we can fully contribute to our nations. All right, Ms. MC, I think that's all my presentations. So I think
Thanks.
sorry. Okay, I'm open for any questions.
Yeah.
From any questions?
Thanks. Thanks, Encik Ismail Hadi. Thanks for the very interesting talk. Yeah, how we can use AI in smart farming. So
yes.
So now we will take some questions. There is one question from someone in the audience that would like to know, if we use all this technology, will it actually increase the cost?
Hello. Hello.
Hi, I'm not sure what happened to Mason. Maybe I'll continue. Yeah. Okay. By the way, I'm Nozarin from the technical team, so I will continue with the question. Yeah. One of the question is asking about what is the overall cost of deploying these technologies, especially if we want to deploy at a large plantation.
All right. So I think if you really want to deploy this technology, we can look at the cost solely. We also need to look at the overall spending for this project, because if you use this technology, meaning that your input cost will be lower. So for example, if one plot of 1 hectare, we've been using, for example, 100 bags of urea, but using the technology, you can reduce it only to 50 bags. So when you put in the cost of the drone, etc., but when you minus the cost of the fertilizer, then overall cost will still be within your what I call your budget. But what will give you the benefit is that you will have a better harvest.
All right. Yeah. Thank you, Mr. Ismail Hadi.
All right.
Right. Let's take another one. Okay. There's one from Tip Wom. He's asking, I'm not sure if it's he or she, does your company offer internship?
Okay. I think for the next season, we are open for internship. So if anybody interested to come in, and then we are also now planning to have one intern from University of Malaya. So he plan to join us in December. So and then the next season we plan for maybe about Jan or February. So if anybody interested, I think you can email to me as well.
Maybe you can share your email.
All right.
I think
I think I have my email inside the brochure by the WAI Summit. Or otherwise, how can I put in my email now?
Maybe can you type it out? We can show it as a banner.
Okay. Right.
Okay. What is it?
Right. Okay.
Okay.
I think you can use this one.
All right. So
and also for your information, we are also now doing another 2 agriculture project. We do chili farming, and also we do a mushroom farming. Mushroom farming, basically we are using a new what I call it, a modern method of mushroom farming, And for the chili, we are doing the fertigation chili farming. So maybe I think we are open for any student that perhaps you want to have, you want to collaborate with us to, for example, do the mapping of the pest control for the chili, or you also want to maybe do some AI studies of the effect caused by the humidity inside the what I call it, mushroom tunnel, at what range that the mushroom production will be less or will be more. I think we are open for that. All right.
All right.
Yeah.
I think your MC is back. So I'll
All right.
give the stage back to
Apologies,
her.
yeah, I got disconnected. I think there's too many people online. Must be that it's a public holiday. Everybody in my area is online. So
Okay,
the
all right.
internet connection is not that stable.
All right. Okay.
Okay, so let me quickly see what other questions that we have. Yeah. Okay, other than this question is from Arif Rahimin. Other
Okay.
than climate and weather, is there any other disturbances like wild animals such as crows or eagles that can interrupt with data acquisition?
Oh, okay. I think if you talk about the satellite image, the size of the animal is so small, so it will not affect the data acquisition so much. But if we fly drones, but I think even the drones, I think the size of the crow or the eagle will not be even 1 pixel of the image. So I don't think it will affect the image so much.
What about, I'm just curious, what about lightning? Because we are talking about tropical weather, so we have a lot of thunder and lightning. So will lightning, strike some of the drones out of the sky?
Okay, I think now based on the I would say that the safety of the drones, I think most of the drone right now have its own if I'm not mistaken, humidity sensor. So if it started to detect the water drops from the sky, and then the drone will back to the first waypoint, and it will land by itself.
Oh, I see. Okay. There is one question relating to cost. Yeah.
All right.
Someone from the audience. So it says AI solutions and big data will come with a cost, especially for computing power and for purchasing servers and so on.
All right. All right.
So is usage of this technology, is it going to affect the cost of delivering the project?
Okay, I think if we solely, as I mentioned just now as well, if we talk about solely the cost, definitely if you want to add in or top up any technology, it will cost you more. But I think if you look at the overall cost, we top up on the technology, but I think if we can reduce a lot from the inputs, I think in overall you will still have the same cost benefit for your exercise. But I think the one that will be benefit you is basically you have a more harvest.
I see. Okay.
Yeah. So
it
for,
does justify the cost, right?
yeah, it will still justify the cost.
I see. Okay, that's good to know. Second question is from Mark. What is your opinion on the technological acceptance of these farmers? Generally, the farmers in Malaysia are much older. Are they ready to accept change? Are they technology savvy enough to adopt the solution?
Okay. All right. I think Mark gave me a very tough questions. All right. Because I think we took it this way. For the very old generations of the farmers, I think it's very tough for them even to accept drone to replace their human for the pesticide spraying or a form of fertilizer granulating. They still prefer human to do it. But for roughly for a middle age of farmers, in between 30 to 40 to 50, I think they are start to open their mind, that they start to realize that by using drone to do the pesticide sprayer is actually much efficient and much faster than using the human. So I think maybe another 5 to I would say that 5 years. I think our agriculture field and agriculture exercise will change so much, and people will start looking that, okay, this is this is where they can have more more time to do something else rather than they need to spend the whole day at the farming. And then they can see that by having this drone basically can tackle the pesticide much faster than using the manual way. I think this is another consideration where we need to start putting into the market, and we need to start setting our foot, and we need to start to show result. For example, I think a good result will always give a million stories for the farmers right now.
And I think our government is also trying to encourage, right?
Yes. I think
wider adoption.
yes, I think our MAFI, Ministry of Agriculture and Food Industry, also promoting IR 4.0 drones solution, etc., for small farmers to start engage in this new technology.
Right. Okay. And the next question is from Rahmat Shazi. So he would like to know more about the algorithm. He says that other than the S3 prototype drone, can you also you mentioned about the algorithm? So he like to find out more about the algorithm and how it is related to the integration that you have mentioned earlier.
All right. I think this will take some time, but I would appreciate if Rahmat can send me an email, and then I think we can discuss from there, because I think if algorithm, because now we are not talking only on the software, because I think we have two types of software. You have one type of software that don't relate any GIS to it. So meaning that you have two type of programmer. One programmer is a standard programmer. Another programmer is the one who have the GIS programmer. So ours is more on the GIS programmer, because any program that produced by our team for this algorithm need to be tied to the GIS, because it has so many inputs. For example, one plot, if you map, for example, if you map one plot at 9 o'clock in the morning, and another plot at 10 o'clock in the morning, and another plot at 11 o'clock in the morning, you can't have the same data for it. You need to do the light intensity according to the time. So that you can have, for example, and then that's why from there, we are also at this moment developing our own spectral library. So we can have that when we fly. And another consideration is that when we talk about remote sensing in Malaysia, we need to remember one thing. Of course, if you studies in the universities, most the lecturer will tell you that the data is homogeneous. It's actually, if you go at the what I call it, the field, the data is not homogeneous. So, and the data is basically we call it locality. Locality meaning that whatever you measure, you come up with the algorithm. For example, in Sungai Besar that we are doing right now, you can't really use it to add in Kedah just like that. You need to go there, you need to fly drone again, you need to do the calibration again, you need to do the locality mapping again, then only you can use that algorithm in that area. So we are talking about one algorithm that can suit all. We need to have the algorithm, and then we need to combine the locality to that algorithm.
I see. Okay, so
Right?
means that it's not as simple as just taking something off the shelf and use it, because you need to customize it, localize it.
Yes.
Right. And then this question from Izati Ilyas. So this one is along the same lines, yeah. So the question is, in a business perspective, is it more economical and efficient to use proprietary algorithm that is developed in-house, or is it more economically viable to just use available machine learning solutions out there provided by cloud providers?
Okay. I think the providers out there, as I mentioned just now, they will only give you a standard algorithm, meaning that if you use the standard data, you will get what you want. But if you need to do the calibrations to the data for according to the locality, then you can't just simply using any software to implement any tools for that. So you need a specific tools and a specific software. So that's where I think we learn from our mistake previously, where we try just use any the software that available in the cloud. and then we try to implement it. And at the end, when we do the ground checking, or we call it in situ measurements, and we compare to the results processing by the desktop, then it show a different results. And then from there, we start to realize that every locality have its own preference and its own characteristic. So we need to identify that first, and then and then you can use any machine learning or any solution provided by any cloud providers.
I see. Okay. Okay. So, maybe one last question.
All right. Okay.
Because we are almost to the reaching the hour.
All right. Thank you. Okay. Understood.
So this is a question from Arif Rahimin again.
Okay.
So is there any plan to use this technology other than, in the agriculture field, other than what you have mentioned, like we branch into palm oil and so on?
All right. Okay. I think we need to understand one thing first. What is the biggest what they call it agronomy in Malaysia? So we have only one. We have the biggest in commodity is oil palm, and we have the biggest in the what they call it the staple food is paddy. So that's why we focus on these two. But of course, I think perhaps our future would be, I think everybody knows that now the Musang King, the durian is very famous. Right? So maybe one day the Musang King will require this technology to really support the Musang King farming in Malaysia. So who knows? But I do believe that when you have the right algorithm, it can be applied to many things. It can be applied to many crops and to other potential, what I call it, farming as well.
Okay. Yeah. Musang King, it's quite it brings in quite a lot of revenue for the country. So yeah.
Because and then I think people is the people farming it is also growing. The area is also growing. So maybe it going to be another the third major contributor to the Malaysia after palm oil. It could be Musang King and then the paddy. Who knows?
Okay, yeah. So, and also the fact that Musang King, it's quite specific to Malaysia. Very few countries produce durian like us. So, yeah, I think it's a good area for us to capitalize in.
Because what I heard from the market and also from the Musang King player is that I think they have tried to plant it in Indonesia and Thailand as well. But because of the soil conditions there, they can't really get the quality that they have in Malaysia. So that's why in Malaysia, I think the Raub is one of the best locations to plant Musang King. So frankly speaking, I never seen anybody come up with the paper yet on the different output of the what they call it durian Musang King pulp compared to the soil conditions. Maybe I think anybody from the researcher from the university would like to do it. I think then it will be
it's a very interesting. I'm sure it's quite easy to get government grant as well.
Because I think you look at the market right now, as long as we have the China as the one of the major consumer for this Musang King, then this business will go on and on and on, definitely.
Yeah. Okay, so we are reaching the hour. So just want to apologize if there are some questions that I didn't manage to ask. So but not to worry. Encik Ismail Hadi will be in Topia tomorrow. So Topia, that is happening. It's a platform for networking. Tomorrow we have a session for networking. So if you are interested in Encik Ismail Hadi's solution, or if you are interested to work as an intern, or if you are interested to do a postgraduate industrial collaboration with Encik Ismail Hadi, so please join tomorrow's networking session. But of course, you need to be a paid premium ticket holder to be able to join. But I guess if you have if you are looking for internship, if you are looking for business opportunity, or if you are looking for technology solution, then tomorrow's networking solution will be a very good platform for you. Okay, so we will also be sharing Mr. Ismail Hadi's slides. So if you want to reach out separately, you can also do so. And with that, I would like to thank Encik Ismail Hadi's time to introduce us to using technology in smart farming.
All right.
Okay. Thanks, Encik Ismail Hadi. Thanks for your time.
Okay. Thank you so much for invited me as well. All right.
Thanks. And just a quick announcement. The session later on why accelerate is cancelled. So the next session will be starting at 3:45 p.m. So it will actually be the WAI Talk 8. Okay, so do take note, yeah. We will not be starting at 2. Instead, we'll be starting at 3:45 p.m. With WAI Talk 8, Sustainable Use of Water. Okay, so yeah, with that, I will close the morning session, and then we will see you again at 3:45. Okay, thanks. See you later.